Okay, good morning, everybody. Can you hear me? Yeah, thank you, Darren. How about the others? Horace and Jess, Calvin, can you hear me?
Yes,
Yeah,
yes.
yeah, thank you. Very good. We should have 14 students, but I can only see four now. So let's start first, and hopefully the other guys will join to this WebEx training. First of all, welcome everybody. I will introduce myself, but I want to wait a little bit more until more people join this WebEx. First of all, please prepare that you can speak. Hopefully, we can all talk to each other during this training. And then, as I send you the invitation, you create the account, and then you should be able to join the Slack group just like Jess, you can hopefully type something inside the channel. So we can share files, share link using the Slack. Okay. Thank you very much. Please just try to type a message in the channel. Okay, so that everybody can participate. Good morning, Evan. Uh, yeah, Josen, Darren. But in this class, there may be a few students cannot speak Cantonese, so we deliver in English. But if you got question, you can ask me in Cantonese. Anyway, that's good. Now we got five students. Let's start first and wait until a little bit more people join, and then we let me introduce myself, and hopefully I would like to know your background as well. We got 14 students. So I'm Brian from actually AWS authorized instructor. Uh, yeah, I help AWS do a lot of webinars, seminar, workshops. As you can see in the picture, some of the event is very big, more than 1,000 people attend. But that's 2016, 17, 18, 19. Okay, starting from 2020, as we all know, the pandemic. Now we have many webinar. Okay, rather than physical event. So uh, the training time for this sections for these 3 days, we start at around 9:30, exactly 9:30, and then we will have around 1 hour lunch break. Okay, hopefully we can start that in 12:30. All right, around 12:30, we will have 1 hour lunch break. But likely we join together with some lab so that it provide more flexible. You can do the lab first and then have lunch first, do the lab, or have a longer lunch, and but you need to do that at night. All right, so this is your choice. Make it more flexible. So uh, this course, we will discuss a lot of things, but mainly focus on big data. All right, the big data ecosystem, and then we will discuss the Hadoop, but actually in AWS, this is Elastic MapReduce (EMR). The component inside EMR is very heavy. This topic, how we can launch those cluster, what application we can run. You got some lab working with some application inside the EMR cluster. The programming framework, ad hoc analytic, this is related to Athena, really a lot of service that we are going to talk about. And then in-memory processing, okay, you also have a lab working with Spark, okay, how to analyze those big data. And the storage option, uh, also real-time analytic. Okay, in this area, we will discuss Kinesis family, the Firehose, the Kinesis stream, together with the analytic. All right. Once again, ad hoc query, we use Athena, but also for ETL, we will discuss Glue, what Glue can provide. And data warehouse, we will take a look on the Redshift. Actually, there is another 3-day class, mainly just talk about Redshift. Here we got one topic to let you understand what Redshift is. Okay, and then that's the analytic database, support a really huge amount of data. All right, and in our second last lab, lab 6, we will integrate something together with the Redshift. Okay, so one of the lab we will play with who just the interface of your EMR. And then in one of our module, we will talk about cost, and the other module, we talk about security. Okay, security of running big data on AWS. Okay, and then the ingress, transfer, compress, this is also huge, very important in the big data world. In the last module, we talk about some visualization option. Of course, we can use AWS QuickSight, but in our lab, we will use Spotfire, okay, to visualize your application. And orchestration, of course, is also important because we don't want too many human involved. Human make error, right? So for the attendance prerequisites is that actually a little bit familiar with AWS Service. Okay, here we will not talk about what is S3, what is EC2, what is VPC. Suppose you're already familiar with some basic service. So for solution architect or data scientist, data analytics, this is the target for this class, target audience for this class. All right. So prerequisites, big data technology terms, and hopefully, if you join the technical essential or the awesome day, you got some background, understand what AWS is. Okay. So some additional prerequisites, we understand the core AWS service, like we have a relational database, DynamoDB, and also we understand what is EC2, basic networking. We've got different types of service like the region bind, global bind, and also AZ bind service. And a little bit familiar with the Apache Hadoop and then Hadoop file system. All right, basic understanding on SQL, NoSQL. This is some prerequisites. But later on, I will take a look, understand your background so that I could be more customized in this training. All right, so let's take a look on the agenda. We have 16 module. Module 1 is just overview, a very short module, overview of big data. Okay, so get everybody in the same page. And then the module 2, we talk about how we ingress, collect, or inject the data into AWS. We have a lot of method through the internet, through the, say for example, if you have VPN, direct connect, or one-time offload all the petabyte data to AWS using the slow family. So different method of ingress data into AWS. And then module 3, as you can see here, we have a lab, okay? And module 3, we take a look on the streaming data, okay? And use the AWS service, Kinesis, okay? So after we finish this module, we have a lab, and this lab take around, this number is the minute, all right, to run the lab on average. Some people, if you're very familiar, you may finish it within 20, 30 minutes. But some people may take longer time, maybe it's an hour, okay? So this is on average, the people take around 45 minutes to finish this lab, all right? Kinesis, of course, I will do a little bit demo, but the lab provide you all the hands-on, okay? And then module 4, we talk about storage solution. Instead of just putting everything in the HDFS, rather we may put some raw data in your data lake, likely S3. Maybe some data you put it in RDS, DynamoDB, and likely we may put some process the data into Redshift. Okay, so where we can store our data. Okay, and then module 5, we will take a look on the ad hoc query. Okay, here we will discuss Athena. Not only we will discuss, but also we will have a lab around half an hour. We play with Athena. Okay, so that's day 1. And day 2, we have a lot of lab to do, but sometimes the agenda may change every class. In some of my previous class, we can start module 6 in day 1, but some other class, we might only cover 4 module in that day. So every class is a little bit different. But generally, in day 2, we will discuss module 6 to 10. Module 6, we have a lot of lab related to EML. EML is AWS version of Hadoop cluster. All right, so we already have the Hadoop cluster, and then try to store, query those data together with the DynamoDB. Okay, so interact with multiple AWS service. DynamoDB, as we may know, this is a NoSQL running on AWS. NoSQL, the data is stored on SSD, interact with the EML. Likely, we may have some semi-structure, no structure, the data. All right. So, and then EML, how we are going to use EML and how we are going to provision the EML. Okay, so module 7, we will talk about that. And then module 8, we will take a look on the programming framework. Like inside, we will discuss what is Hive, what is Pig, and a little bit discuss on Spark, but we got another whole module talking about Spark, but we got another whole lab on that. And for web interface, actually we use Hook. Okay, so that yeah, we use the console, the UI of Hook, and then pay with the Pig script. Okay, so we got 4 labs to do, but sometimes in some previous class, the lab 6 we might do it in the final day. We might also swap the topic. It depends. Okay, depends on the time. And day 3, we will discuss Glue to help us on the ETL data category, and then some job orchestration. And then module 12, we will discuss what is Redshift, what is the position of Redshift. Actually, this is the OLAP database for analytics, store our historical data, okay, and then ready for visualization. And then we will talk about security and cost. Both are very important. And then module 15, visualization. Okay, we will also have lab using some third-party tools, Spotfire, to visualize your project, okay, your data. And then module 16 is just very short, some architecture, some design, some example. All right, so this is our agenda. So every day we discuss 5 or 6 module. All right, so everybody, you should already receive this license code related to your ebook. The ebook is actually our PowerPoint, but PowerPoint I cannot deliver. Okay, I signed agreement with AWS. I cannot even deliver to AWS staff, my colleagues, or everybody. So you have the ebook. You can read the ebook for 2 years. Yeah, actually, it covers every single slide and link, just like the PowerPoint. All right, you can print it out, but 10 page a time, or you can download offline with the Bookshelf app to read the ebook. Okay, for ebook, you may have multiple versions, 3.8 through 3.9. You just take a look on the latest version. Okay, so that's for your reference. But after 2 years, the ebook you cannot read again, will be self-destroyed. All right, because likely 2 years, everything outdated, especially in the cloud environment. So I would like to know your background. Now we got a little bit more people inside my class. hopefully get your headset ready. Let me introduce myself first. I'm Brian from Hong Kong. Okay, and then my background is I've been teaching in the IT field for 20 years. All right. Uh, yeah, and I'm the first AWS instructor in Hong Kong. At the moment, I'm also VMware instructor, also Citrix and Microsoft instructor, but more than 80% I deliver AWS training, especially some advanced training. I got a lot of AWS class. Now I teach not only the basic technical essential, the architecting training, but advanced architect, DevOps, the Kubernetes, EKS, and this the data big data, data warehouse migration. Actually, I teach almost everything in AWS. That's my background. And not only teaching, and I also involved in a lot of projects. Some project is very big, some project is quite small. Actually, in the year 2019, the Q3, Q4, I stopped teaching for half year, for helping some company move their infrastructure to AWS cloud. All right, so they use high performance cluster. I can actually have a lot of sharing with you. That it can also run big data. Okay, actually they got more than 8 terabyte data every day generate related to financial record analyze and yeah invest in the stock market. Okay, so it's quite interesting. So not just teaching, and this is my background. I would like to know your background as well. Let's start from the participation, from the participant with the alphabetical order. Okay, so Elvin, can you talk? Is your mic okay? Good morning, Elvin. Are you here? Yeah. You don't have a mic at the moment, but please try. Just like as you can see in the name list, I got the iPhone. All right, join together in this section. So if my laptop got any problem, I still can talk using the iPhone. So you can use another device, maybe your phone, maybe your tablet. Okay, join, and then you can talk. Okay, hopefully we can all talk. But anyway, if you cannot speak, can you type your background in the chat area? Like, uh, yeah, are you using AWS Big Data Service already, or you are using still on-prem? If so, what is your role? What did you use? I just want to know your background and your expectation of this class. Okay, so please type if you cannot talk. And how about the next guy, Darren?
Good morning. My name is
Morning.
Darren.
Yeah, morning. Yeah.
Organization is Harry Logistics.
Mm-hmm.
I
Okay.
am a solution architect doing C# programming,
Mm-hmm.
Postgres SQL. Big
Yeah.
data involvement is a Kafka.
Mm-hmm. After.
MSK managed service,
Mm-hmm.
managed streaming for Kafka.
Okay. So, did you use any AWS big data solution service already?
Is Kafka considered?
Mm-hmm.
Okay.
All right.
Experience, I'm associate solution architect certified.
Mm-hmm. All right.
Expectation. Today, I want to deliver the big data to my web application
Mm.
using API and etc.
Okay. So, did you try the EMR, Kinesis, something like that before?
So far, I tried only Athena.
All right. Oh, Athena. Okay. Thank you very much. So hopefully doing this training, after this training, you understand, maybe you can try a little bit more service provide natively from AWS. And one question I would like to ask, is the examination important to you? Big data examination, analytic examination.
I think in the associate
Mhm.
solution architect is very little about big data, very
Mhm.
little.
Yeah. But there is another analytic examination. Is it important to you? Because some students they focus on examination. They need to finish the exam in order to claim the money. But is it similar or no? You don't need to take examination for big data for analytic. So I just want to know.
I don't have examination in my milestone,
Okay,
so
okay,
I'm
that's
only
good.
here to get the knowledge.
Yeah, that's good. So can you speak Cantonese? Because I saw you say
係
早晨. All right.
我係馬拉呢度嘅，就
Okay.
呢度嘅人都有講普話噶啦。
Okay. But doesn't matter. All right. We'll deliver in English if you can ask in Cantonese if you want. All right. Thank you very
No,
much.
I'll do English.
Okay.
Thank you,
Okay.
Brian.
Okay. Thank you. So that's all I want to know. Yeah, your background, your expectation, what you use. Next one. Horace. Is it Horace?
Hello, can you hear me?
Yes. Hear you.
Good morning. I have been working for about 4 to 5 years and
Mm-hmm.
as a data analyst.
Mm-hmm.
I just start using AWS service about for one year or
1 year.
maybe less than 1 year. Yes.
Okay.
The function I mainly use is some simple Athena,
Athena.
SageMaker,
Mm-hmm.
and Glue.
Okay. So did you
Yes.
try uh the EMR, Redshift, something like that?
No, that
All
the
right.
Redshift I'm really interested in.
Mm-hmm.
Yeah,
Okay.
how to put the data into an organized database.
All right. Thank you very much. Okay. And yeah, Kinesis. Did you use Kinesis before?
So mainly use
Okay.
SageMaker, Glue, and Athena.
All right. So machine learning that direction. Very good. Is examination important to you?
I think no, not in this
Okay.
one.
Okay. Thank you. That's enough. Next one, Jess. Jess Tong. Can you hear me?
Yes, this is
Yeah.
Jess.
Yeah.
I'm also from the carrier logistic. Okay.
Mm-hmm.
Right now I'm a software engineering manager for carrier logistic in Malaysia. So I use AWS near to 4 years now. In the beginning of the journey, I think I most of the time involved in building the application and hosting in AWS using the serverless architecture.
Okay.
And after that, I'm more toward on the team management and architecture solution on on-prem and into the cloud. So I think for this class, for me, my expectation will be look into the big data knowledge and hopefully can get enough to equip myself to prepare for the data analytics specialist certification. Yeah.
Okay. So examination is important to you.
Yeah.
Okay.
So for the concept wise, I think big data is not new to me, but for the hands-on experience, I need to more get involved on the hands-on.
Yeah, very good. Yeah, you got 7 labs to work with your hands-on. So as you mentioned, you pay with the serverless technology. Can you name some service that you work with?
Mainly surrounding the Lambda.
Okay.
Yeah, Lambda, Fargate, and DynamoDB especially.
All right. That's good. Okay. Thank you very much. So you are now based in Malaysia, right?
Yes.
Okay. Thank you very much. And then next, Kelvin.
Hi, can you hear me?
Yeah,
Good
yeah.
morning. And I'm Kevin. I'm come from MTRC as a data analyst, and I have around 1 year experience with AWS, mainly using Lambda, Athena, Glue, etc., and SageMaker. Yeah.
Okay,
Uh,
okay. So it's
uh,
very similar to Jazz, right?
to Horace because
To Haran, sorry.
yeah, we are college. Yeah,
Yeah.
actually. Yeah.
Okay. So is it the examination, is it important to you?
I think yes, because actually the exam provide a structured way for me to know more about AWS. So
Okay.
it is quite. I think it is through the exam. It is quite meaningful to me
Okay.
to learn more about AWS in a structured way.
Okay. Thank you very much. All right. So, the last one is Ted. Is it Ted? Can you hear me? Oh, no, your name, no, Okay, so if you don't have once again, you can join with a mobile phone, and then or you can type your background into the chat area. So Tech, hopefully, and Elfin, yeah, please try. I would like to know your background as well. But anyway, we keep going first. For those who just joined, please try to type a message in the Slack channel so that we all in the same group. So when we are going to use the WebEx chat, when we are going to use the Slack, they looks a little bit similar. For this free day, of course, we will use the WebEx. But every time I turn off the WebEx, everything gone. All right. I have a lot of link files to share with you, so we use the Slack channel. In the Slack channel, you can ask me out of the class time, even at like 8 p.m., 2 a.m. You can still ask question, and I will keep this Slack channel to the end of next month. Okay, so as you can see, this is a date. Remind me when we are going to delete. Okay, because every week I got class, I cannot support everybody forever. So for this channel, we will keep until September 30. All right. So next week, next month, you still can ask me question. All right. So I will support you guys for a while. All right. So yeah, that's the Slack channel. Hopefully everybody can join. And what you should prepare is that you should be able to see the lab. All right. As you receive an email from AWS China, go to aws.quakelab.com, create a lab account with the email that you provide. If you want to change another email, it is possible, but you need to let me know. All right. So everybody should be able to see this purple area. All right. After you log in to aws.quakelabs.com, see this purple area. And if you go inside, you can see that there are 7 labs for you to do. All right. The lab could be open up to 11:45 p.m. Wednesday. All right. So you can do it at nighttime as well. But you can only do the lab 3 times at most, every single lab. Okay. I can tell you half year before, you can do 1,000 times for every lab. But now we can only do 3 times because somebody used the lab to do the Bitcoin mining before. All right. So in order to avoid that, there is maximum. All right. So just say you want to change the email for the lab, right? To your
Yes.
Okay, let me just change it now. So if you want to change the email that you register, yeah, tell me. So let me remove, this is personal information, so I better put it into another screen. And then for Jess, I remove your existing and then use a new email. And then you should be able to see the lab. Let's everybody please just try to see whether you can yeah, see the lab in your account, the purple color. Can you see that, everybody?
I'm
Yes.
I can't see my lab. Maybe
You cannot see it.
am I using the MTR.com?
Let me check. Horace.
Let's start with a CHEN. CHENMAHH.
Okay, let me double check. CHENMAHH.
Is that
Uh,
the NTR account?
Yes, NTR.
Ah,
So there are two methods that you can do to see the lab. One is you use your company email to create the lab account. The other method is just like Jess. You give me another email and then I change it.
another email then.
Okay. So you type
Should I
in the
just
chat
type in
area.
the chat room?
Yeah. Then I replace your existing one. So everybody please try to go to login AWS Quick Lab to see whether you can see this purple color. Please try to do it now. See the lab. Yeah, if you didn't register yet, you can do it now. It takes just 5 minutes. Okay, I change it for Horace. So I will remove your company account and then replace this one. Okay, you can check now, Horace. Can you see the purple color?
Yes, thanks.
Okay, you can see now, right? Very good. How about some other people like Kelvin, like Tag, Elvin? Can you see the lab? Yeah, this one. Very good, Darren. You can see the lab. How about the others? Elvin and Tag, Kelvin. Can you see the lab? Do you need to change?
Yes, I can.
Yeah, very good, Kelvin. So Tag and Elvin, can you see the lab? Okay, so if you cannot see, you tell me later. Let's keep going. After this 3 day, you should be able to get the completion cert just for your attendance. But in order to get the completion cert, you should join the WebEx for 2/3. It means around 67% of the time you stay in the WeChat, in the WebEx, sorry. So this is some regulation from AWS, all right, training team. So please stay in, yeah. And for, say for example, Tech, you have 3 other colleagues join the training, right? So please ask them stay in, join the class. Okay, let's start. Let's keep going. Yeah. So we just introduced the course, myself, and then yeah, let's keep going. The first module, let's take a look on what is big data. Yeah, the big data, actually, this module is just a little bit short, define what is big data. Not just the volume is very high, but also the variety and then the speed of the data coming into our system could be huge also. So we define big data. Take a look on some example of big data and what tools we can use inside AWS Big Data. So what is big data? Actually, what is the usage of big data? Mainly, we use big data to answer questions, all right, to make decisions, okay. Actually, 15 years before, I also play with the analytic big data, but at that time, I'm still Microsoft guy. I use the product, okay, build a crib analytic service to answer those questions. But nowadays, the data is much more and then much more frequent enter into your system, and they might not be very structured. Okay, so this is for us to answer questions. For a lot of business, try to find your target customer, try to increase the revenue. And for some other company, let's say in Hong Kong, Macau, I deal with some electricity provider, all right? So they focus on how to minimize the cost. And then because of the pandemic, I teach not only the people around APAC, I teach a lot of US company. They literally living in US and also Europe, okay, UK, Sweden, Norway, a lot, all right, India, Australia, all around the world because of the pandemic. And some country in Europe, I don't tell you which country, all right, they actually, some class, the client investigation deployment, join my training. And they just want to analyze, try to reduce the crime, all right, by using the big data. Okay, so this is not just for revenue or cost, but maybe to make the world safer, all right, and more healthy. But we can answer the questions. So to gain advantage, just make the world better, all right. So for big data, actually, what is big data? As we can see here, the data is so large that we need to think about how we are going to collect, store can be a few seconds, a few minutes, or half a year, forever. All right. So how we are going to handle those data, organize, analyze, at the end, visualize, and make decision. All right. Answer questions. So this is the overview. And then nowadays, actually, when I first teach big data, we got only 3 V's. Okay. Sorry, let's come back. Like velocity. First of all, the volume. Okay, we got huge amount of data, not just gigabyte, maybe terabyte, petabyte, or even exabyte of data. And then the velocity, the data going into our system could be 100 in a second, or could be a million in 5 minutes. All right, so the velocity, the speed going into your system. And rarity means they're not necessarily structured. Okay, 10 years, 15 years before, likely we have structured data. Okay, the table, we have your order, your customer, the dates, the age, they are very structured. Nowadays, we might have a lot of event, okay, a log file. A log file is just record of the event. Maybe they are very unstructured. Your application server log, your authenticated server log, anything happen, all right? So because of our unstructured, how we are going to process those data? Okay, we use different method, and Hadoop cluster play a big role in that. And then veracity means the accuracy of your big data. And at last, we have the big data have value, because we might have some pattern. We might be able to do some forecasts, use our existing data to guess, to analyze which country you are going to sell most, which product you are going to make next, where is our target customer, how can we save costs, how can we reduce client, how can we nowadays in the COVID-19 avoid the spread of the virus. Okay, so this is related to big data. And if you go to Google search, now they may say 6, 7, or 8 V's. Okay, but actually they're important to us. Then we take a look on the big data pipeline. Actually, for the whole course, we discuss around this pipeline. Just like next module, we will talk about data ingression. Okay, next module is module 2 and module 3. We talk about how we ingress the data, or in other words, collect, inject those data into our pipeline. Okay, and then we have storage. Module 4, we are talking about the storage. Once again, can be a few seconds, can be minutes, months, years, or forever. All right. Say, for example, our data lake, I would just want to keep the raw data forever. All right. And then after you store those data, okay, and then we process the data, a lot of module, okay, from module 5 to module, I think, 10, 11, we are talking about processing the data, okay? You can use a lot of tools to process. Some of you already play with Athena, and then we will discuss the EMR Hadoop cluster, and then we can using the application inside the Hadoop cluster, like the Hive, Pig, Spark, to analyze those data. And you can use third-party tools as well, all right? And then after that, we will talk about security costs. And our last module, we will talk about the visualization so that the manager, okay, the boss can make decision, okay, answer those questions by using this big data by night. And the important concept is that 10 years, 15 years before, it might take a long time, okay, from you ingress the data. It takes weeks, months in order to make those decisions. And now we might want to answer in some project, we might do other testing. Okay, now in some project, we might want to answer the question much more quickly. Okay, let's say where do we have COVID-19 case? We don't want to wait until 2 weeks, 4 weeks because already spread. Okay, so the latence depends on your business, your application. Okay, sometimes we may just want real time. Okay, so that's why in module 3 we talk about Kinesis. It focuses on real time. All right, yeah, that's the pipeline. And of course, you can use everything provided by AWS. So as you can see here, if you use everything from AWS, this is some AWS service. We can see the Kinesis family. When you see Kinesis, this wording means real time or nearly real time. All right, our first lab, you'll pay with Kinesis family. All right, we want to answer the question quickly. We want the pipeline, the latency very short. Okay, maybe just seconds. Okay, we can start processing those data. And then apart from real time, we might use some one-time migration. All right, import our data into AWS. Okay, offline using the Slowball. All right, actually we got some project before helping a university in Hong Kong moving around 80 terabyte data to AWS. Okay, this is just one time. Okay, and then you might use queue service, but we are not going to discuss queue service in this training. Actually, in our architecting on AWS 3-day training, we have some module talking about the SQS. SQS mainly for the communication between service. All right, and Amazon, the parent company of AWS, use really a lot of queue service to handle their application. Okay, of course you can use EC2. It means the virtual machine. You can collect the data from there. You might install the agent of some third-party tools. Some people here might use Kafka or use the Fluentd from, okay, some third party. You can install the agent, still can ingress, collect, inject those data into the pipeline into AWS. So after you ingress those data, and then this is the storage surface. In module 4, we are going to talk about much more detail. But of course, in AWS, we likely store our files, our object, raw data in S3. Okay, if you just want to keep those data in a cheaper price, then you can move to Glacier. Okay, some of you here already pay with DynamoDB. If there are no SQL, okay, this is a very good place for us to store those data. And then actually you can see Kinesis stream. Okay, we store the data, but not permanently. Okay, maybe just a few seconds. We store a few seconds and then start process. Okay, So this is nearly real time. We will discuss much more detail in module 3. The difference between Kinesis stream and Firehose and some use case. And then relational database, if they are relational, we can store in RDS. Okay, and the other storage is that the Redshift. Okay, Redshift, it is really interesting and very useful for big data analytics. So this is the data warehouse. So once again, DynamoDB, if for search data, we might use Cow Search or Elasticsearch. Elasticsearch is more or less in the processing side. For data store, you may also use AWS IoT, and then once again, DynamoDB for on-demand. And you may also store your data in the Elastic Block Storage, just this storage. And then for processing the data, okay, actually we got around 3-4 modules talking about the EMR. Okay, this is one of the important topic related to the big data. If you just want ad hoc query, yeah, I think that can help you. All right. Some of you already play with the Lambda. Just run your function, run your code, stateless code using Lambda function. You can actually run any code in Lambda function. And then Kinesis data analytic, traditionally, we can use SQL statement to query our stream data. But nowadays, there is a lot of enhancement in Kinesis analytic. Okay, some of them is very new, just launched for 2 months. We can have a studio playbook work together with your stream data. And some of you already play with machine learning, the SageMaker. Okay, so you may use machine learning to interact with your big data. Elasticsearch, okay, and then for ETL, we might use data pipeline or Glue, but what's the difference? We will talk about that later. And then, of course, you can use QuickSight to process your data, but QuickSight is mainly focused on data visualization. Okay, and then for analytic, yeah, we can also, once again, use Kinesis family. And Elasticsearch, to be more specific, this is the Kibana, all right, to do the visualization. So this is all provided by AWS. So you can do the big data pipeline with everything provided by AWS. However, if you still want to use some third party because you're already familiar, maybe you move from your on-prem data analytic to AWS. I'm expert already, just like some of you in Kafka. All right, you can still use that. The key message here is that you can use any open source, any third-party tools with AWS. Okay, mix and match. All right. Suppose you still have a lot of file moving into the pipeline. I don't want to use Kinesis. I don't want to use the anything provided by AWS. You can still use, say for example, if you already use Front and Log4j, all right, you can install those agents. This is moving files to AWS. All right, install the agent in EC2 in your on-prem device and ingress. Okay, inject into AWS. And for Fluentd and SQL, it's basically for the stream data. All right, suppose you got stream data, you can use, actually myself, because I work with some project with Kubernetes, we use Fluentd, okay, to stream those data into AWS. So this tool is for stream data, and this tool is for file, moving files. File, maybe it's just some log file, some record of event. And then to store those data, you may still store in the Hadoop file system. Okay. When you create provision, the EMR cluster, there is some storage locally inside those cluster. You can store there. All right. However, we recommend you store somewhere else. All right, like S3, DynamoDB, the Redshift. Okay, because in AWS, we want you to decouple. All right, so that if we don't need to process, we can terminate the whole EMR cluster, all right, for saving costs. Okay, maybe in a day, I just process the data for 4 hours. So you don't need to pay for those 20 hours. You just terminate. The most important thing is your data. Your raw data, your processor data is there, okay, in the storage surface. If you can do that, you don't need to store in HDFS. However, this is your choice. You can still use Cassandra, but in AWS, the DynamoDB is look like quite similar to Cassandra. Can you move that? Some of you pay with Kafka. You can still use that. Okay, HBase. These are all open source. Okay, not just this. There are many. All right. Some of you may use SAMC and some other Flink open source data processing or technology before. Okay, so for processing the data, you might use the Hadoop, but actually in AWS, the EMR is AWS version of Hadoop cluster. Okay, in module 6 tomorrow, we will talk much more details. And you might use Spark inside the Hadoop. These are some application inside the Hadoop cluster. All right, so you can install inside. You just check the boxes. When you launch the cluster, you can have all those application together with you for the cluster. So we will discuss Spark, Hive, Pig, Postgre later. For OZ, actually it's for workflow, okay, workflow management. And MAHOP is basically the machine learning, okay, another open source. Maybe you use SageMaker, that's the AWS version. You use some open source, then you can use Apache MAHOP. Okay, Impeller is also for distributed execution engine. All right, so the key message, once again, you can use everything provided by AWS or use open source. For visualization, I still remember more than 20 years before, when I'm still a student, I used SAS to analyze, to run the regression. And then, 12, 15 years before, I was a Microsoft guy. I play with the Power BI. Okay, but nowadays, I know a lot of people use Tableau. In our lab, we will use Spotfire. Of course, AWS QuickSight. Okay, so visualization, you can use this or some other. All right, just like many years before, people use business object, the ClickView, the Crystal Report, something like that. Okay, so visualization, you can use any existing tools. So let's take a look on this big data architecture. For this big data, we have the pipeline, the data bugs. As we mentioned before, we got some ingress, collect, inject your data into some storage. Once again, could be second, minute, years. Okay, if you are processing real-time data, likely you just store a few seconds using the Kinesis data stream, and then you start processing. Okay, as you can see here, storage process. And I can tell you traditionally for Hadoop cluster, people have a lot of machine, okay, grouped together in their on-prem environment, and they store the data, all right, in the HDFS file system, a distributed file system, and then not only store those data, but also use the same machine to process those data. And now decouple means we better break the storage with process. Instead of using those same machine to store and process, okay, we decouple, break it down. Maybe here you store in S3 and then use EMR to process. And then we store in somewhere else, maybe Redshift, maybe Kinesis, and then we start another process. So that if you don't need to process, you just terminate those resources to reduce your costs. So this is what we should do in the cloud environment. Okay, don't waste your budget, don't waste your money, okay, if you're not processing. Okay, and there is a lot of advantage because for storing, AWS got really a lot of huge service for storing your object. The most important is your data still there. So let's take a look on how it looks like together with the service. Let's say here you got your data ingress, maybe real-time data. I want to ingress into Kinesis family. And then I just want to keep all the raw data in S3 to build a data lake. And then you use the file host. File host actually just move your data, okay? And then we keep all the raw or source data. And then in Kinesis, after a few seconds, we start processing those data. Okay, we don't want to wait 2 weeks, 3 months. So store a few seconds, and then EMR start processing. Okay, so you can process using any supported code language method. In EML, likely you might use Hive and Pig or traditional MapReduce, and that's why we call it MR, Elastic MapReduce. Okay, so after you process your data, if they are very structured, you can save in RDS, Redshift, or if they are still semi-structured, okay, you can put it in DynamoDB. And then maybe at the end, some of the data processed, unstructured, you may put it in S3. And then, we moved those data at the end to Redshift. We keep appending data into Redshift for analytics. And then at the end, you use QuickSight and take a look. As you can see here, we decouple storage, process, storage, and at the end, analyze. You can do a few more iteration, okay? Storage, process, okay? And that's the flexibility, okay? Once again, if you don't need to process, just terminate those resources. That's the best practice. Or once again, you can use third party. Here, you may use Kafka, you may use From, you may use some other third party if you want, okay? So let's take a look on the data pattern. It depends on whether your data is structured or not. Okay, as we often mention, EML is very good for the semi-structured, even unstructured data. Actually, we got some project, their data is financial data. In China, they invest in the equity in the 3,000 Chinese Shanghai market. All right, their data is very structured. Okay, in that case, actually they don't need EML. Okay, I can tell you another cluster called before it's called high performance cluster. Now they call it parallel cluster. It's very good for the data structure, for the structured data. All right, even if they got 10 terabyte of data every day generate, they will those financial company in my previous project, they use those analyzed data in order to make the trade. It means the buy and sell decision, okay, automatically without any human intervention. So if you have some unstructured or semi-structured data, EML is your choice. All right, so it depends on your data structure. Of course, you can use some other tools, like some of you already use Athena or some other method, Lambda function, in order to analyze. And the latents, nowadays, say for example, once again, COVID-19, we don't want to know the result anywhere, got spread, got virus after 1 week, 2 weeks, okay? So we want to know immediately, okay? Some of our customers want to know, say for example, at the moment, how many percentage of user connecting to my application using Android, using iOS at the moment, okay, now, okay, so in this case, the latency is very short, then they tend to use Kinesis, all right? But if you want to analyze for the past year, how many notebooks sell in America, okay, so you may have a longer latency. So it affects what tools you are going to use. And then throughput, okay, do we have huge amount of data? And then also you need to answer using parallel process. And for the whole course, we are talking about the distributed processing parallel processing is very important. Okay, a lot of cheap machine rather than one or two very big giant machine, so that it will be easier for us to replace and use. And then access pattern, how your user is going to access the data. Are they using just Microsoft Excel, BI tools, or using QuickSight, using SQL statement or programming language? It totally affects what tools you are going to use. Okay, so next, AWS offer a lot of managed service. You can use everything provided by AWS. Okay, just briefly understand. One important thing is security, and I can say security is the most important. Okay, actually, around 2 years before, I teach one class, security team, and the security team had sit opposite to me. This is a very big giant insurance company in the world. I'm not going to tell you which company, but the security team have the authorization, have the permission to allow or deny the project going to the cloud. All right. If he is not happy, okay, we don't need to talk about anything else. They will just deny the project, go to somewhere. So security, in my opinion, in many cases, is the most important. But I can tell you that running the analytic or anything on AWS in the cloud environment could be more secure than you run in your on-prem, because you offload a lot of job, all right, related to the hardware, the physical, the underlying architecture. Okay, should be much easier and much more secure. Could be much more secure. All right, and then if you just want some disk drive, you use the Elastic Blocks storage and real time. And of course, here it's just brief introduction. Module 3, we will talk much more details on the Kinesis. We have one module talking about Redshift, but Redshift we can talk about for 3 days. Okay, there is 3-day course on Redshift. And then for RDS, it's basically for online transactional processing. And Redshift is based on the online analytic processing. Okay, likely the historical data we want to analyze. Okay, but here is transactional. The focus, the data is focused on now a lot of concurrent access. Okay, NoSQL, and then Lambda function to use. This is likely in the big data pipeline, process your data. All right, Elasticsearch, open source engine, or provided by AWS, the Cloud Search, SQS, the Q service, and then data pipeline for ETL. Likely moving those data from your on-prem to AWS cloud. All right, and what's the difference between Glue? We will discuss that in module 11. And then Beanstalk, maybe you use some web application to collect, say for example, the click stream. You need to analyze the click stream. All right, I really have some company, they are from game company. They need to make the decision. Oh, if they make the game too hard, the player stop playing. If they make it too easy, the players also stop playing. They need to analyze whether they will invite some other people to join the game. Are they going to pay for the game, to buy whatever? All right, so they have many click stream to analyze. Really a lot of game company use AWS. You can find it in case study. And then SageMaker, all right, for machine learning, for us to forecast and do a lot more machine learning job. Yeah, so this is some managed service. Okay, by using those managed service, you offload really a lot of handling to the availability, maintenance things. So there is a case study. Actually, if you want to know a little bit more case study, this is a very good website. Let me get back my Google Chrome. AWS case study. Okay. Last week, the student, they want to know a lot of case. Okay, so inside this case study website, let me just put it into Slack so that everybody can get the link, get the file that I share. So here, if you can actually search the name of this case. If I go back to my PowerPoint, the Test Corporation. Okay, if you search this, you can find the actual case. There are already 2 cases. If you go inside, this is much more detailed. All right. Some of them you may have even video. Okay. Not only this, say for example, I want to know any, now you can see around 2,000 cases. I want to know anybody use Athena. Okay, if you check the boxes, you got 50. I want to know anybody used, say for example, EMR, the Hadoop cluster. There is around 150 cases. Okay, so for this case, actually the training material just grabbed from the case study website. Okay, if you want to know more details, you can go to the official website. It's about the click stream. All right, they want to analyze the click stream, their application. Okay, every day they got really maybe millions of click stream. Okay, they want to analyze. All right, and then get some data visualization. So the architecture is like this. Okay, Elastic Beanstalk is just hosting some web application. Okay, maybe the user using their laptop, using their mobile tablet. Okay, connect to the Elastic Beanstalk endpoint. Okay, so when they click something in their mobile, okay, here we collect. So they don't want to analyze after a few weeks, a few months. They want to analyze now. So that's why they use Kinesis, okay, to ingress the data. All right. So after Kinesis store for seconds, all right, the EMR, they spin up the EMR cluster to process those data. Okay, you can imagine the Kinesis data stream is just store the data for a few seconds. Okay, and then the EMR start processing. Okay, using the open source programming framework like we will discuss, Hive, Pig, something like that, or Spark. Okay, so details go back to the case study, and then the processed results save in S3, and they may develop another EML cluster. All right, work together with Redshift and SAS to have the decision making, and then this is for modeling for machine learning, and then aggregated data. Okay, they put in Redshift and then use Elasticsearch, likely Kibana, to visualize the product. So this is one example. By doing that, they have a lot of increase on the clickstream analyzing. And then most likely for many companies in case study, they reduce the cost much faster, analyze more. All right. So this is the idea of using everything provided by AWS. Okay. Most of them provided by AWS. Okay. So this is the module 1, just an overview of big data. All right. Eric, you want to find the redeem code? I can find it for you, but you can try to search first. If you search your email, Gilmore. If you still cannot search license code, then I can find it for you. Okay. So you can try first. Now we got more people join to. Darren, you are asking about the data science toolbox. Can you elaborate a little bit more on your questions, Darren?
Can you go back to the previous slide about the hubs?
Previous slide. Okay, let me get back the slide first. Wait. And which one? This one? You are talking about this one, Darren?
Yes.
Yes.
From S3,
Mm-hmm.
then to the left side, there's
Okay.
data science.
Oh, you mean this?
Yes.
All right. Actually, in AWS, there are many tools for you to do the development. For the developing class, we will talk about that. Nowadays, we really recommend you use the Cloud9. Did you use Cloud9 before?
No, but I've seen it. It's
Did-
Visual Studio Code inside the browser.
Not just Visual Studio, a lot of coding that you can use, even Python, Ruby, Java, Node.js. This is a very good tools for you to use, or even container. Oh, so there are many choice. If you are familiar with Eclipse, if you are familiar with Visual Studio, you can integrate it with AWS. But actually, yeah, nowadays, if you don't have any preference, this is a very good tools. But this case study is around 2014, 15. They may be outdated. Nowadays, many people use a lot of codebook like Jupyter, like some other, like in Kinesis, we have Studio Codebook, but you get my point. Just use some familiar tools that you can use. Did I answer your question? But I can go further to search for this case study, what they use.
I see. Its meaning is IDE, integrated development.
Yeah.
Understand.
Okay, you get the point? All right. So let me try to answer every question first. You can ask question directly or using the Slack. Okay, Anthony, the slide, actually, I have PowerPoint, but I cannot distribute. You, in your ebook, you should get all the slide, but electronic book format. Okay, so first of all, did you get the license code? If you search Gilmore, okay, so after you get the ebook from the bookshelf app, Fatal Source, you should be able to see the ebook, right? Can you see the ebook, Anthony? Okay, so inside the ebook, yeah, there are 3 or more ebook. Take a look on the latest version. We should be 3.9 now. And then there is a lab book and also the student materials. Okay, for the student materials, actually it's the same as my PowerPoint. Can you see that? How about Eric? Okay, Eric, can you get your ebook, the materials? Okay, very good. Yeah. Okay, let's keep going. Eric, can you talk? Because everybody already introduced themselves, I would like to know a little bit on your background. And Timothy, if you have no mic, can you just type your background in the chat area in Slack, or you can talk? Okay, you are typing. Okay, so doesn't matter. If you don't have mic, then you can type your background. I will want to know, and then yeah, hopefully later on you can use another device, phone, to join the WebEx, and then let's talk. Okay, and Anthony. All right, anybody got more questions? From yeah, Eric got it. Okay, thank you. And Jess, hey, is case study website profile reference architecture? For Jessie, your question, yes, some of the case study provide architecture, but if you want to know more related to architecture, I actually got a much better website for Jess. If you go to this is my architecture website from AWS. this one is much better. I put it into Slack. This one is really good. Okay, because some of you may be architecture guy for data analytics. You don't know how to start building the architecture, drawing or use any surface. So this website is once again from AWS. All right, official page. This is my architecture. Now they got more than almost 600. Okay, say for example, if you want to use EML, all right, we got 46. Okay, and then from many company. Okay, some of them is very familiar. Okay, so you can take a look, and they are just actually YouTube video and elaborate what service they are going to use. Okay, say for example here they use Kafka. Maybe some of you use EML, use Elasticsearch, and then 6 minutes talking about how they use AWS to build their data analytic architecture. So this is a very good link for your reference. Is that good to you, Jess? Okay.
Yes, very good. Thank you.
Okay, so this is a very good reference example. Okay, let's start a little bit more in module 2, and then around 11 we will have a break. Okay, so if you got any questions, you can ask in the WebEx chat or Slack. Once I see those questions, I will try to answer your questions. Okay, so module 2 is about ingress data. All right, so module 2 and 3 is also about ingress. Yeah, let's take a look. Once again, we saw this data pipeline. Okay, yeah, in the pipeline depends on what service you are going to use. Not necessarily AWS. You can still use the tools that you're familiar, open source tools. We need to ingress the data. Here we say collect, ingress, inject, whatever. Okay, just move those data. Maybe one time, maybe continuously, maybe ad hoc, or maybe batch. All right, so it doesn't matter. So we store in somewhere some storage service. Once again, could be seconds, minutes, hours, forever. All right, and then we can start processing those data by using different method. Like some of you use Athena, and the heavy topic EML, Spark, HivePay, or some other tools. Okay, and then it may do a few iteration, a few times. Okay, we firstly put the data and then aggregate, and then later on we do further ETL, massage, whatever. All right, and then at the end we visualize the data. Okay, the last module is about visualization. Module 2 and 3 is about collect. Module 4 is storage, store your data, and the rest module likely we focus on process. Of course, we got 2 modules talking about security and cost. Okay, so that's basically linked with the agenda. For data ingression, actually we collect the data, and then after we collect, we store somewhere. All right, seconds, minutes, hours. So for data ingress, first of all, we take a look in this picture diagram. We have different types of data. Okay, traditionally, we have database data, transactional. All right, for database, actually, it is around 50 years. Microsoft SQL, Oracle, MySQL, around 50 years before, 1970s. All right, you got insert, update, delete, select. But nowadays, we got some unstructured NoSQL data. All right, I should be saying no relational. Okay, so this is traditionally web server and then application server passed to database. Okay, very traditional. And now since we got a lot more unstructured data, you may capture the files. The file may be just some likely the log file, record all the event. All right, say for example, somebody visit your web, your application, and something happened. they successfully get something, they fail to do something, all right? And those data may come from device, may come from nowadays a lot of mobile application, browser, some digital video recorder, all right? Maybe from their game, sensor, IoT device. Okay, nowadays a lot of things connect to the internet. Think about the webcam in the drone, and then in the street. Okay, so really a lot of data. And then, of course, you can use some open source tools like Flume and Log4j. This for moving the file data into AWS. Okay, so you can use open source, you can use third party, all right? And then likely, because they are likely the files, we use S3 to store those files, okay? We might have the data lake, store the raw original file, and we can process later, okay? Could be a few hours, a few days, or half year, or we don't know, okay? We just want to defer the process, okay? So because those are files, we store in S3 first. And stream, first of all, we understand what is transactional data, what is a file, but what is a stream data? In AWS point of view, the stream data we define like this, more or less continuously. Sometimes we may have more, okay? Maybe 100 in a second, maybe 1 million in 5 minutes, all right? So more or less, sometimes more, sometimes less, but continuously, all right? So if you are using AWS to move those stream data, ingress those stream data, likely you will use Kinesis producer, all right? Could be agent, could be SDK, could be the creator library, okay, producer library. Or once again, you can use third party, okay? Suppose you use FluentD or Storm or some other thing, okay? So your choice, AWS version, third party version, and those stream data, if once again you use AWS, Kinesis data stream is your choice, okay? And then later on, we start processing those data. So it depends on which data type you're using, but we support all this. Say, for example, this is just example, you are moving the stream data, okay? The easiest way to move data into AWS, the stream data is using Kinesis agent, okay? Just like many AWS service, it offload a lot of heavy lifting, okay? We just install the agent in your source machine, can be EC2, can be on-prem device, just any Linux-based machine, okay? We can only install in Linux machine. Suppose some of you is Windows guy, what should I do? Then in that case, you may use some other producer, all right? We use the Kinesis producer library, can be installed in Mac, in Linux, in Windows, or maybe even mobile device, all right? We use the library or even SDK to do so. But if your source machine is Linux machine, okay, maybe some box, some hardware, virtual machine, it doesn't matter. Then we install the agent and we can ingress this data into Kinesis stream or Firehose. Okay, next module, we will talk about the difference. Okay, but here, high level is that Firehose actually just transfer your data into, say, for example, S3, Redshift, or nowadays we support a lot more destination like Datadog, third party, Splunk, and just transfer your data. And then for data stream, actually, it categorize your data for your later on processing, okay? Instead of just transfer the data. But we will discuss much more details next module. Maybe you just want to capture the log file, okay, from your web server, log server, database server, all right? And then by using this, we can monitor, all right? And then we handle a lot of heavy lifting, like file rotation. Okay, I just put all those files in a single directory, and then we can rotate those files. Oh, this file finished, next one, and then we can checkpoint, and then anything fail, retry. So you don't need to write the logic, how you retry, how you handle the file rotation. Okay, so it's the easiest way to move the stream data into AWS. Okay, we also support pre-processing. Okay, maybe we want to aggregate the data, change some format, okay, before we move to AWS. Okay, so this is Kinesis agent, but if you say, oh, I'm not familiar with the agent, but I'm already using Froom. Okay, I use Froom agent. Actually, before Kinesis, I can tell you, Kinesis come to the world in 2013. All right, a lot of people before 2013 use Froom. All right, maybe 2010, 2011. Okay, at that time we don't have Kinesis. Okay, but they already use Froom agent. It's similar to Kinesis. Just install the agent into your on-prem machine, your device, your EC2, and then ingress those data. All right, so this is just open source method, as we mentioned. Move your files into AWS. Okay, so next, Kinesis family Froom for stream data, okay, for real-time data. And then what's next is we have the pipeline, right? The data pipeline. And then maybe some of your data is already in S3, okay? And then maybe some of your data in database, relational database, okay? So how we are going to move this data? Okay, maybe likely here we use the EMR. We have the EMR cluster. Okay, we have the HDFS Hadoop file system. Okay, so how we are going to move the data? All right, maybe you have the on-prem Hadoop cluster. This is on-prem, the Hadoop cluster. Okay, Hadoop, still HDFS. Okay, this is on-prem. So this two's S3 distributed copy is very good for you to move the data between the Hadoop file system and S3. Okay, maybe you're on-prem to S3 or S3 to EMR if you have those needs. Okay, so move a large amount of data between S3 and Hadoop file system, no matter in the cloud or on-prem. Okay, so the key wording here is this is distributed. So this is not a single thread movement. Okay, this is distributed processing, parallel processing. Okay, a lot of thread moving those data. It means that it is very fast. Okay, one thing related to transfer data, the consideration, if you move data into AWS, you don't need to pay for data transfer. All right, of course you need to pay for the storage. However, if you move out, no matter you move through the direct connect or VPN, there is data transfer fee. Okay, for your understanding, in US, data transfer out through internet is 9 cents US dollar per gig. Okay, in Hong Kong is 12 cents. And then direct connect is 2 cents. Take a look on the pricing. There is some consideration moving in or moving out. Okay. Of course, you can use some other tools like DataSync. Okay, DataSync is totally another service. We install a virtual machine in your on-prem virtualization like VMware, Hyper-V, and KVM. We only support these three. Okay, VMware, Hyper-V, and KVM. And then after we install agent, we create some tasks to migrate those data into AWS. Okay, and they say AWS is 10 times faster than the open source engine. All right, so keep automatic transfer data between on-prem and AWS. Suppose you might have originally the on-prem Hadoop file system. Okay, I want to keep moving those data to AWS. This is one method. Okay, likely we store in S3 first. Okay, so this is S3 distributed copy. Okay, we can do it inside EMR as a task. So we can move it to AWS Hadoop file system, or likely we store it in S3. Okay, we support compression. Okay, once you compress, it means much faster, and then also less data transfer through the internet. Okay, so this is for transfer data between S3 and HDFS. And how about database? Suppose my data is in my on-prem relational database, maybe on-prem Oracle, on-prem MySQL, Microsoft SQL. So the next tools you can use is this one, SQL to Hadoop. All right. Actually, this term is SQL, SQL to Hadoop. Okay, that's why we call it SQOOP. All right, SQL to Hadoop is basically moving the data between your relational database, not just AWS. Maybe you have your on-prem Oracle, Microsoft SQL to HDFS. Okay, it's bidirectional. Okay, inbound and outbound. Once again, if you move data back to on-prem, data transfer out, there is a cost associated. Okay, it can be a MapReduce job. Yeah, so we will talk about MapReduce in module 6, and then yeah, we can use it for ETL. Just say, for example, another example, in our EML, after we finish processing the data, let's say save to Redshift, okay, write to data warehouse, okay, because here it's just processing. After we finish the process task, move all those data to Redshift, okay, we still can use these tools, okay. Move to a data warehouse, and then later on in your data warehouse, you use some visualization tools like QuickSight, Jaspersoft, or Spotfire. Our lab, we will use Spotfire, all right, or Tableau. A lot of people nowadays use Tableau, all right. So let me finish this slide, and then we take a short break. Suppose you have on-prem, okay, more than 90% of the people have on-prem environment. Their data source may be relational database, maybe just file, okay, it depends. You can move using VPN, okay, but VPN actually using internet, okay, maybe not so stable, not so fast, but anyway, moving in, there is no data transfer cost. If you want to have a more stable connection, direct connect, this is FiberLink, but direct connect, we need some time to set up, all right? Normally, maybe weeks, okay, 1 or 2 weeks. But VPN, you can set it up in half an hour, all right? Suppose your on-prem equipment is ready, okay? So yeah, data transfer in using the internet or direct connect, or if you just use internet, okay, suppose I can upload to S3 directly. You may use the multi-part upload. Multi-part upload means it break giant file into small part, all right? Actually, by using the command line, okay, AWS S3 copy or synchronize, it will do the multi-part upload automatically, all right? You don't need to do anything. But if you upload through the console, there will not be multi-part upload. Okay, if you upload through command line or SDK, yeah, you can use the multi-part upload. Okay, so that easier to resume, break it down, much more faster moving those data to S3. Okay, but still, maybe go through the internet or direct connect. However, if I got really a huge amount of data, okay, I got 100 terabyte. Okay, it is better for us to move offload by using some hardware device, Snowball or Snowball Edge. Okay, Snowball Edge is basically the second generation. Okay. Some people want to ask a question. I heard some voice. Okay, if you want to, yeah, ask question, yeah, anytime. So next, when we are going to use the Slowball, if you got 100 terabyte data or terabyte of data, you can use the first generation or second generation. Slowball Edge is second generation. It means that we can run the Lambda function EC2 instance inside. All right. But if you got exabyte of data, you may use Snowmobile. All right. But you need to check which region we have Snowmobile. All right. In order to check which region, what service we have, you can go to AWS region table. And then say, for example, in Hong Kong, my region, okay, if you search for snow, there is only Slowball. All right. If you go to Virginia, okay, you search snow, there is Snowmobile. All right. And maybe some student here from Malaysia, likely you go to Singapore, right? Let's go to Singapore and then search snow. Okay. Oh, still Snowball. All right. Not every region got all the service. So this is a very good link for you to take a look and reference. Okay. So this is moving really huge amount of data, maybe inside our on-prem traditional Hadoop cluster. Okay, and then I'm going to have the data center expire. The contract is going to expire. I want to move to AWS. This is the use case for that. Okay, Slowball, a hardware machine. You order, they deliver the hardware to your office, and then you move those data. They're originally encrypted, but if you don't want, you can encrypt one more time, okay, before you load to Slowball, and then you can check the process. Normally, it takes around 2 weeks, 3 weeks back to AWS. And at the end, you can see all those data in S3, all right? It takes around 200-300. It depends on your region, okay? So one-time migration. And then for Slowball Edge, is the second generation, 100 terabyte nowadays. You can run Lambda function and also the EC2 instance inside. All right. Some shipping company in the middle of Pacific Ocean, they still need some compute resources. They use that. All right. Snowmobile, you can move petabyte or even exabyte of data using the big truck. But yeah, take a look on your region. Okay, so do you have any question now before we take the break? Let me check whether the check WebEx. Any questions so far? Is the speed, everything good, everybody? If you got any suggestion, please tell me now. Do not wait until Wednesday. I hope everybody, yeah, enjoy, and hopefully we can keep doing that. Is that good, everybody? The speed, the content. We are going to take, how about 15 minutes? Now, Hong Kong time, 11:10, around 11:10. Let's come back 11:25. Is that okay? Is that okay, everybody? Hong Kong time. So let's take a break first. Okay, let's continue. Everybody come back, right? Can anyone give me some response? Yeah, thank you. Thank you, Darren. Thank you, everybody. So let's keep moving. Once again, because some people join a little bit later, we have a Slack group for sharing the link, materials, files, wherever. So if you are not in this Slack group, please provide me your email address. I just add you into the group, okay, so that you can get all those resources. Yeah, let's continue. Module 2, once again, is related to ingest your data into the pipeline, into AWS. The most important thing is ingress the data securely, durably, all right? Yeah, and if you use some managed service to do so, you don't need to handle those heavy lifting, okay? Offload to AWS. Another method to ingress your data into AWS is using, nowadays, a lot of people use IoT device, okay? Really a lot of IoT device, maybe in your home, maybe in your industry, okay? Your company, all right? Your customer, all right? Think about the camera, anything measure the temperature, all right? Especially in the COVID-19, yeah, we need a lot of data, okay? So the IoT device, a lot of people is already using, building those IoT equipment, okay? So we may support billions of device, trillions of message, okay? So this is another good method to move those data into AWS. If you use AWS IoT, you can tightly integrate it with Lambda function, Kinesis, S3, or even some other service. Okay, so let's take a look on, let me just get everything first. And then the IoT, name some definition. For those, some of you take examination, the terms, the keyword is important. Okay, first of all, for development, you use the SDK, AWS IoT SDK, to develop your application. First of all, your device, no matter this is any internet thing, any device, cam, whatever, need to be authenticated first. In order to authenticate, the device need to have the XDOC 509 standard certification. Of course, you can integrate with Cognito, all right? Is the authenticated service for mobile device, mobile app, all right? So you need to authenticate. And then inside those IoT, inside AWS, we got a registry. Actually, it's a central repository of all the device. Suppose you got a billion device, then inside here, you can see all those device, all those definition. And then this is the IoT API you can develop. Actually, IoT in AWS point of view is just some ingress method, okay? And then you control the outbound messaging method, okay? Some message we receive and what we are going to do. And then in order to communicate with those devices, you can support HTTP or the MQTT, okay? A lot of IoT use MQTT, this protocol, just protocol, all right? And then we have the rules engine. And in AWS IoT, the easiest way is that you can use SQL statement, SQL-like statement to inside the rules, what you are going to do. And then we can integrate a lot of AWS service, like Lambda function, night notification service, DynamoDB, S3, whatever service. And we have Shadow, because your device may be offline, okay? Shadow is just represent those device when they connect to online and connect to your AWS environment, all right? And then we push those command to those device, all right? So this is how AWS IoT device work. And actually, for the past several years, a lot of our customer student develop those IoT applications, okay? This is one way to ingress the data. There are a lot of data. Okay, let's say just an example. Inside some AWS case study, the shoes, all right, need to measure the temperature. All right. If think about in a shoe, if say for example the water, okay, increase the temperature for 1 or 2 degree, the sharks may die. All right. So it is really important to measure. This is just some example. The webcam, the industry devices. All right. So you can build and ingress those message into AWS and to do the further analyze. All right. So if you want more use case study, go to AWS case study and search for check the box IoT. What are their architecture? The rules engine, once again, is just SQL statement. Okay, how you are going to move those message. All right. We want to take a look on the chain. All right, to answer the questions by your managers. All right, we support JSON, we support where calls in order to run those SQL statements. Okay, and then for IoT rules engine, once again, it integrated with a lot of AWS service like Lambda function. Run your stateless code, store your data, maybe video, maybe picture inside S3, DynamoDB, and notification. Okay, something happened, notify somebody. All right, and then it can also integrate it with EMR, Kinesis, and show it in the dashboard, search, Kibana report, something like that. Okay, tightly integrated with AWS service, and that's why a lot of people use. Even some of my students, they are actually student in university, and nowadays a lot of final year project use the IoT. All right, for their final year project. Okay, 20 years before they do the data mining as the final year project. Nowadays, a lot of students really use some IoT device together with the AWS free tier to make their final year project. All right, so this module is about ingressing your data. Okay, let's take a look on some answers. What are the methods that you can use to move data into AWS? Direct Connect, VPN, S3, multiple upload, Slowball, Edge Mobile. All right, and then Slow Mobile, we can transfer up to 1,000 petabyte data. And rules engine is just like inbound method. Actually, you can have this answer in your ebook and then move those using SQL-like statement. All right. And the easiest way to move those data, ingress data to Kinesis. Next module, we are going to talk about Kinesis Firehose and Stream is the agent, but it only supports Linux machine. All right, at the moment. Okay, so this is module 2, some concept related to the ingress method. Okay, and then next module, we really take a look on Kinesis, and we have a lab on the Kinesis, and hopefully we will do the lab in the lunch hour. Okay, even if we didn't finish this module, let me show you how to start doing the lab. The lab is just some hands-on that you really work with the AWS product. Some student may ask, is it compulsory to finish the lab? I would say not compulsory, but recommend. Okay, the lab can be done before Wednesday, 11:45 p.m. All right, anytime in the midnight you can still do it, but you can only do the lab every single lab 3 times at most. Okay, because you are using a dedicated account. Let me show you how to start the lab first. You don't have all the privilege. Okay, suppose the lab you are going to work with Kinesis, you don't have permission in Redshift. You cannot use the lab account to create a Redshift cluster. Just do what the lab wants you to do. Sometimes students do something wrong. All right. Suppose they give you create permission to create a Kinesis data stream, say for example. And if you did something wrong, you may not have permission to modify or even delete. All right. So you may as well stop the lab and start again. Okay. So you can do it 3 times at most during this 3 days. So I need to make sure that everybody can see this purple color, all right, for the lab. If you cannot see, because some of you may change to some other student, you don't have that email, you give me your new email, but what is your previous registered email? So I delete the previous one and then add you in so that you will see the lab. We will do the lab together with the lunch. The lab 1, let me show you how to start the lab. At most 2 hours, all right? But normally lab 1 here, it suggests that for normal people, it takes around 45 minutes, all right, to do the lab. Okay, you may do it faster, slower, all right, but at most it's 2 hours. After 2 hours, everything will be gone. Everything is temporary. Let me just start the lab first. One thing to remind is that it takes time for the lab to start. Okay, so if you do it after the lunch, before you go to grab your coffee, before you go to toilet, you better start first. Okay, but I will perform the lab a little bit later. Anyway, it is better for us to start doing the lab after this process finish, because they are creating something, the lab environment. If now you want to do something, maybe they don't have the resources ready. Okay, so but if you do in the middle, something create and not all, you don't have permission to remove, so a lot of trouble. You better wait until the start finish. And then one other thing to remind, if you got any existing AWS account, remember to log out first. Okay, otherwise it will remember the browser will remember the previous credentials. After each lab, you should log out. Okay, otherwise it will remember the previous credentials. Okay, so that you may not have permission to see anything. All right, so the user account is AWS student, and then I can just type AWS student. Okay, and then the password, and then the lab guy is actually here, all right, in the middle. So it is better for you to have 2 devices so that you don't need to switch and flip and see the step, do the console, all right. You have another device, log in, and then you can see the step. Yeah, and after this is the step 1, start the lab, open the console, and then take a look on what we are going to do first. For this lab, okay, we are going to create Kinesis application, okay, analytic application, and then connect the stream with the application, use some SQL statement, and then transfer those data to S3. Okay, that's the purpose. Okay, handling your streaming data. And then if you go down here, yeah, what service you are going to interact with. We have some application server. All right, that's why we need some time to provision. API gateway, but the API gateway is already created. Okay, the stream is already created. All right, so you are going to work with the Kinesis, Analytic, and Firehose and S3 bucket. So they ask you go to Kinesis. All right, let me just start how to start. So ask you to search, go to Kinesis. Okay, this is Kinesis, and then data analytic. Do not go wrong. Data analytic application. Okay, analytic application. All right, and then sometimes because we are using the real AWS account. Actually, this is not just lab account; it's real environment. The name may change. All right. Nowadays we call it analytic application. Maybe before maybe last week, it is called data analytic, all right? But actually, you should be able to find, if you cannot find any area for the lab, you ask me, okay? Since we are using the production real AWS environment, AWS keep changing, improving new features every 4 hours. We got new features. Something may change. Okay, it is usual. So wait, my monitor got some problem. Let me share again. Okay, my monitor come back. All right. Again, so let's go back to the lab. It asks you create application, and then you are going to put the name, description, and then this is the step for you to follow. Sometimes you see the error. Maybe the error is expected, so you take a look, and then there is 4 error, and then you may try it a few times. This is some code you already have it. You just copy. Okay, this is a copy button so that you can copy the SQL statement. This is basically SQL statement: create table, and then insert. Okay, select, and then select statement. All right. So you interact with the AWS Kinesis family. All right. So let's move on. How you start the lab. If you still cannot see the purple color, cannot see the lab, you let me know. All right. So let's keep going. When we talk a little bit more at around 12:30, we have the lab together with the lunch. Once again, around some people join a little bit later today. At around 12:30, we have 1 hour lab, 1 hour lunch, and 45 minutes lab. Okay. Once again, you can have lunch first and then do the lab, or do the lab first and then have lunch. But do not do a few minute lab and then go to lunch and come back and continue the lab, because at most it's 2 hours. Okay, don't waste the time. Okay, yeah, that's the scenario. Let's keep moving. This module is about Kinesis. The key point of using Kinesis application family is real time. Okay, I want to have real time information. Okay, how many user connecting to my application, what device, what OS they are using. Okay, any new information related to the COVID-19. Okay, something like that, real time analytic. Okay, so the need for stream processing and real time analytic. Okay, so once again, this pipeline, this module is related to a little bit connect and also process. Okay, and storage. Okay, so if you are using Kinesis, not the open source engine, once again, the easiest way is using agent. Okay, Kinesis agent to ingress your data, but only support Linux machine. If you have Windows machine, you can use the Kinesis producer library. Okay, so it support a wide range of language, but most people use Java and Python. Yeah, and then to consume, you can use the client library. Okay, of course, you can use command line SDK in order to run your ingress your data. All right, so let's take a look. Let's go inside this stream data. So stream data nowadays is increasing. Okay, a lot of stream data, unstructured, more or less continuously is the definition of a stream data. Maybe your application, your client mobile device keeps sending those data. Could be Kickstream, could be log, could be whatever real-time stream data. Comparing with batch processing, we have interval. All right, 10 years before, 15 years before, 20 years before. We process the data every day, every week, every 3 months. We have pattern. Okay, but for stream data is we don't have pattern. Okay, sometimes more, sometimes less. Okay, that's why we say more or less continuously. All right, and the reason of using stream data because nowadays a lot of application, social media, game, weather, all right, financial. We have a lot of stream data. That's why we need those solutions, and we want to decouple. All right, instead of storing everything in some big giant machine, we decouple storage and then also the processing. All right, we want to preserve the order. All right, so when you produce those data, okay, in order, we consume those data in order. All right, we can have really a lot of stream so that we have parallel processing. All right, so that's why AWS create Kinesis in year 2013, and then really a lot of people is using that after that. Okay, so for stream data, we want to reduce the latency. All right, we want to analyze, make decision, answer the questions right after we get the data. Maybe just a few seconds, minutes. Okay, not days, weeks after we got those data. Okay, by using those stream data, if you use Kinesis, we guarantee the message delivery according to the order. All right. And here we see this word Lambda architecture. One thing we need to mention that is totally have no relations with the Lambda function. Okay, this is a general terms in the big data world. If you search Lambda architecture, okay, in Wikipedia, okay, and then this is not Lambda function. It's about big data processing. Okay, we have 3 layer, batch layer, speed layer, serve layer. Of course, it will be easier for us to take a look on the diagram. All right, let's say here, and then you can see how we ingress the data, batch them, okay, and then speed layer, we might use some in-memory, just example, process, and then serve layer so that the output, the user, take a look on the result visualization. This is a big data general terms for Lambda architecture, not our Lambda function. Okay, if you want to know a little bit more, you can refer to this link or the diagram. Let me find a good diagram for you. Maybe this one is very good. Also from AWS, the Lambda architecture, 3 layer, okay, batch, speed, and then also the serve layer, serve the people to make the decision. Okay, so here we have the stream data. Okay, we might want to make it, we have the window to aggregate the data to process. All right, we don't process every single message because we may have millions, thousands of message. We aggregate those data in order to process. And then fault tolerance is important. The next slide here, we talk about in order to have this window size is basically just aggregate the data for further process. All right. You can take a look on this screen, but I think it will be easier for us to take a look on the diagram. I have a very good diagram related to this windowing. And later on in my demo, I will show you the windowing as well. Okay, so let me put this picture into Slack. And as you can see, we have fixed, okay, maybe just every 5 minutes, okay, half an hour, we batch all those data and then try to process, okay, sliding, all right, so that we swap in between, and section-based, maybe some of them, the windowing is larger, some of them is smaller, all right? So go back to this slide, you can see the fixed, sliding, and section-based data. How you are going to aggregate those data for the processing, all right? It depends on your downstream. If you have a very big giant machine, you can process tens of thousands data. at the same time. If you don't have those big giant machine, maybe you want to have a smaller windowing. It really depends, okay, how you're going to process. But anyway, by using Kinesis, it is very good tools for ingress, store, and process your stream data. All right, we can handle the windowing. Okay, and if you use the agent, as we mentioned before, many heavy lifting. Okay, a retry, checkpoint, and also rotation will be handling by default. Okay, so let's take a look on this Kinesis streaming. Nowadays, we got 4 members in this family. Okay, in this big surface, we got Firehose. Firehose is the easiest way to move your data. Okay, we have the agent, we have the produce library. We just ingress, collect, ingest those data securely, durably. Okay, and then it transfer to somewhere else. It just transfer your data. Nowadays, we can do a little bit modification, transformation inside using Lambda function or using the native converter format. All right, I will show you in the screen a little bit later. And then, but by using Firehose, you move your data, there is some latency. All right, you don't get your result after 1 second, 2 seconds. Okay, we need to, as we mentioned, windowing, buffer. Okay, a lot of stream. Okay, stream record. All right, into smallest is 60 seconds. Okay, so your destination maybe S3, Redshift. Okay, the most nearly real time is 60 seconds, but you can batch the data up to 900 seconds. Okay, so 15 minutes. All right, 1 minute to 15 minutes, you will get your data. Okay, not next second. So another very powerful features service is that you have Kinesis stream. Okay, you can have your agent send the data to Kinesis stream, and Kinesis stream mainly just categorize your data. All right, let's say your application, you have all the mobile phone connect, are now categorized all the Windows mobile go to one SHA, all right, one category. All the iPhone, all right, go to another category. All the Samsung or Android device go to another category. All right, so you have to categorize your data into different SHA. But the benefit of using this stream is that from you ingress the data to get the data ready for process, normally is within 1 second. Okay, we call sub-second. Very quick, very fast. But the consideration of using data stream is that you must have some application to process those data. Maybe those applications are running on EC2. You need to write your application. Okay, maybe you can also use Lambda function, use container, use SageMaker. All right, you need to process your data. Okay, another method is how to process the data. You can use data analytic. It means SQL statement. Okay, instead of using virtual machine, EC2, Lambda function, container, SageMaker, I can use just SQL statement. Okay, and now there is a lot of enhancement. All right, in the data analytic. Okay, you can consider the data analytic is just application to process the stream data. And then we have also the video stream. All right, nowadays, a lot of camera, all right, in the street, in the drone, and then also, especially COVID-19, a lot of thermal heat diagram. So we will have some example. So this is Kinesis family. Okay, nearly real time, or yeah, very close to real time. Okay, so let's take a look on the data file host first. By using data file host, as I mentioned before, is the easiest ways to load your stream data into AWS. Okay, because you don't need to develop anything. All right, you just install the agent and then put all those data into the stream, and then we transfer to the support destination like S3. Okay, I just want to store all the kick stream there. All right, and then later on we think about how we process those data. We can also transfer those data to Redshift if they are already very structured. Okay, move to Elasticache, or you can use the SQL statement data analytic to query those data. It's nearly real time. It depends on your buffer size or time. All right. Once again, 90 seconds. Because in 60 seconds, you may have 5 stream, 5 or 2,000 stream. Okay. What's the time that you buffer? All right, from 60 seconds to 900 seconds, and then at the end to your destination. And now we support a lot more destination. Let's take a look on a few more slides and show you a demo, the look and feel of Kinesis Firehose. So in the Firehose, we support some features like batching. All right, like I mentioned, we batch every 5 meg, 10 meg, or 1 minute, 5 minutes, all right, 15 minutes is the most. We support compression and encryption, okay? And then we can help to minimize, by using compression, we minimize the size stored in S3, and then also increase the security, okay? Your original data may come from mobile device, Internet of Things, or Windows, Linux, whatever. All right, so we use this service to move the data. And nowadays, as I mentioned, we support a lot more destination. So let me do a very quick demo on this Firehose for those especially who didn't pay with Firehose before. So let me do it from the beginning. We search Kinesis, and then here we have the data stream, okay, and then also this one is from the lab account. I don't use the lab account. I use my existing personal account. Let me log in back to my account. And if you take a look on the lab account, they have the data stream ready, but Firehose is called delivery stream. You are going to build it, and then the analytic application. All right, but let me use my own account to do the demo first. So this is my account, and then I have nothing by default. Now let me try the Firehose. You are going to create the delivery stream. Let's say, let me put it in Singapore because I got everything in Singapore. Let's say just my Firehose app 1, something like that. Okay, just a name. All right, and then you can connect the Firehose with delivery stream. Okay, with the data stream. Sorry, the Kinesis data stream. You can connect, or maybe our original source data. Just directly put the data into the Firehose. So as you can see in this diagram, the Firehose, you can have the agent send those data. You can connect to data stream. You can also have the client, the producer library, okay, ingress the data into this Firehose stream. And what are the support destination? We will take a look. Here I just directly have the data, the stream ingress into my Firehose. And then, yeah, this is just some method that you can move the data. Everywhere you can see learn more. Suppose I want to use put API call. I want to use agent. Maybe this one is the easiest way if you are using Linux machine. If you have IoT device that we just mentioned in last module, you got some CloudWatch log. CloudWatch log means just custom logging. Okay, it may come from your network log, web server log, log server, or the authenticated server log, database log, whatever. Okay, CloudWatch event. Now I just keep going. So nowadays you can do some transformation. Okay, if you write the Lambda function, you can do the transformation, maybe filter, maybe some aggregation, maybe you do some some job, some ETL here. Okay, you can do it with the Lambda function. We can also convert the format to PACRIT or ORC. Okay, we will talk about that later. These are all columnized storage. Okay, so that later on you consume the data, you can scan less data to reduce the cost, but also to improve the speed. All right, now I just keep everything default. You can integrate it with Glue as well. In module 11, we will talk about Glue. So I just keep everything default. And then next, now the support destination, you can put it in S3 bucket, Redshift, Elasticsearch, HTTP, maybe HTTP put to somewhere else, post to somewhere else, or we support a wide range of third-party nowadays. Okay, some people use third-party company, Splunk, Datadog, MongoDB Cloud. Okay, now I just store the data in S3, and then a bucket. Okay, of course, in order to stream those data to S3 bucket, you should have permission. All right, the IAM role or S3 bucket policy. All right, so we discussed that in technical essentials or architecting training. Okay, you need permission in order to upload data. Let me just use this bucket, bandwidth file host, short form. FH is file host, from file host. And by default, they store the data in this format, year, month, day. If you don't want this format, you can type your prefix, your format, all right? Actually, it's just like the folder. And then error prefix. Okay, I just keep it default. And then next, and here is the buffer size or window size. Okay, by default, every 5 meg or 500 seconds. It means 5 minutes. I don't want you wait for 5 minutes, so I make it shortest. So we are going to get the data a minute, actually a limit and maybe 20 seconds, okay? Because they still have some overhead connect each other. So you will not get the stream after 1 or 2 seconds. Okay, the shortest interval is 60 seconds. Okay, buffer interval, all right? If you want, you can have the data zip compressed. It is highly recommend you compress the data so that in S3, the storage size and later on, when you get the data, the size is smaller. Okay, it is not only cheaper, but also faster. If it is required, you can have the data encrypt, server-side encryption, okay, using S3 key, using KMS, okay, and tagging permission, okay, what permission you have in order to run, because you may interact with S3, DynamoDB, or some other service. You need permission, okay. Now I just select a previous role that I create with enough permission. So, and that's so easy that I already create this file host delivery stream. Under the cover, the file host delivery stream use data stream. Okay, but you don't need to care about the partition key, whatever heavy lifting, right? The SHA, if you create the delivery stream yourself, you need to handle the SHA. You have the application, you have the partition key. Just after a few seconds, I can then have my file host ready. Okay, and you are going to do it in your lab. And of course, you can change some settings. And what I'm going to do now is I can use the test demo data. All right. If you want to know a little bit more testing demo data, I show you testing data. Demo data. Okay. The official link. Because now I don't have the agent, I don't have the upstream, everything. And then I put it into the Slack channel. Okay. Even if you don't have the upstream, you can use this demo data. All right. Just emergent, like some sensor, pass some data, some price, just some data. All right. And it actually teach you how to create the bucket to store the data, or Redshift, or Elasticsearch, all right, or Splunk, okay? So it is good way to start. And then I start sending those demo data to S3, and then later on, I need to wait a little bit more than 1 minute. I can get my data. Let's go back to my S3 bucket. This file host, all right. And then here, is it? Oh, this is yesterday. Okay, because yesterday is 22. Test the data. All right. Later on, you will see today 23, and then the demo data. All right, but it takes a little bit more than 1 minute. Let me continue some slide first. All right. So go back to the slide. This is file host, very easy to use. Just a few clicks, and then you can start streaming your data to your to AWS environment, not just S3, but also Redshift, Elasticsearch, Splunk, whatever support destination. Okay, very easy to use. The benefit is you don't need to you it's more or less like serverless. All right, there is no provision time, maybe a few seconds, but you don't need to do the ongoing maintenance. All right, it's very easy to use, nearly real time, 1 minute. All right, latency, and then seamless elasticity. It means that you don't need manual change. Okay, if you use data stream, you are going to create a shard, increase the number of shard, decrease the number of shard. Okay, still need some change, but here is all automatically. Okay, suppose you got more and more data. Okay, under the cover at the back end, the data stream will be scaled out, will be scaled in. You don't need to care about that by using Firehose. Okay, but yeah, not as fast as the data stream comparing the time you can get your data to process. So the Kinesis Firehose actually under the cover they use data stream, but you don't need to provision the shard, the partition key. You don't need to handle everything. Just stream your data, your stream record into this service. And then the maximum file size for a data block or a record is 1 megabyte. Okay, if you have very large data, you need to think about how you break it down. All right, from your producer. Okay, maybe Kinesis agent, maybe producer library. Okay, let's take a look on the producer library. Okay, suppose AWS producer library, Kinesis producer library. Okay, so this is the producer library for details information. How you use this library. You can use Java, you can use Python to specify what data you can ingress those data to the Kinesis data stream. So this is the documentation for the development guy. Okay. Okay, let's keep going. And then, yeah, this is producer. All right, send data to delivery stream. That's the file host. And then maybe your example web server send the log to the stream, and I want to analyze those data almost immediately. Okay, as you can see in my demo, the buffer size could be 60 seconds or how many megabyte. Okay, so which come first, and then we buffer those data and then send back to the destination. All right, you can do the transformation. Okay, could be interval, could be size, configurable. All right, but 60 seconds to 900 seconds, it means 15 minutes. So by using data file host, you don't need to care about the partition key, SHA, is end-to-end elastic. You just install the agent, use the producer library or your SDK, and then ingress the data into the SHA and then deliver to the support destination. A few transformation you can do using the Lambda function. All right. So I think the data should be arrived to my S3. Let's go back to my S3 and then have a refresh. And then you see this is just the 23rd is today, is just now. And then this is the sample data. Let's take a look on the latest sample data. If I download, and then I can show you what does it look like. Okay, so this is just sample stream data. Okay, maybe from some sensor, all right, and then the category from health, from financial, from technology, what are the price change, whatever, all right, so that you can start processing. Okay, this is just some sample demo data, all right. And by using Firehose, it is very easy, but not so real time. Okay, 1 minute, 2 minutes later. Okay, and then not so not as so customizable. So you can, if you want to develop, want to have a flexible development, all right, consume your data, Kinesis data stream is your choice. Okay, let's take a look. Why do we need Kinesis data stream? Because I want nearly real time. Okay, maybe just 1 second, 2 seconds. Okay, I don't want to wait for 1 minute. All right, high throughput, nearly real time application, and still cost effective. All right, this is AWS version. So how you are going to do this? Of course, first of all, you have your stream data. Okay, and then you need to have your producer. Once again, for Linux machine, you can directly use the agent. If for Windows, Mac, or other device, the producer library. Okay, and then what you can do is you create the data stream. Okay, inside the data stream, there is some SHA, and you pay for the SHA. Suppose you got only one SHA, all right, and there is some throughput limit. Okay, to ingress the data into the SHA, we have at most 1 meg per second. Okay, suppose you got 10 meg per second, so you need 10 SHA, all right, and then you pay 10 times more. Okay, they charge you the per hour per SHA. How many SHA do you have? And to consume, all right, you need the application, maybe Lambda function, container, or EC2 instance, or wherever, EMR, all right, to consume the data, all right, and then it is 2 meg per second. Okay, you can find those information in the documentation. In examination, they will likely ask you this information. All right, how many megabyte per second read and write? 1 meg per second at the moment. Read 2 meg per second. Okay, and then 5 transaction at every single second. Okay, 1 meg or 5 transaction. Take a look on the official document, white paper. In order to get those documents, let me show you. You can go to, let's say, AWS Kinesis data stream FAQ. FAQ is a very good documentation page for all the product, not just Kinesis stream. Let me just post it here, and then you can find those number. Okay, 2 meg per second output. All right, 1 meg per second input. All right, what is a SHA? It's basically the throughput unit for data stream. All right, especially for those who want to take the examination, take a look on this official document. FAQ is very good place for you to understand the product. And then, yeah, you need to create a stream, and then you also need to have the application to consume the data. As I mentioned, they just distributed your data into category. Okay, and then you may use EC2, Lambda function, EMR, containerized application to process the data. Okay, how you are going to process the data, and later on I'll show you how it looks like yeah, how to create the stream record and then how to consume those stream record. So how to process, we need to integrate it with some other consumer. All right, maybe just EC2, maybe you can use EMR, maybe you can integrate with after process our very structured result we store it in Redshift. But if you still have some unstructured result, okay, maybe we store it in S3 or DynamoDB. Okay, so the storage you can store somewhere using AWS Managed Storage Service. Okay, and then these are some example of the consumer. After you process, we store the result in Redshift, S3, so that we can make a insight using some kind of reporting tools. So by using Kinesis data stream, from you ingress the data to you can get the output normally less than 1 second. All right, that's the reason of using the data stream. All right, and then you need to create a SHA and you start paying for that. For pricing, if you want to take a look on the pricing, AWS Kinesis data stream pricing. Okay, and then take a look here. Of course, you select the nearest region. Okay, for this, I think it's for the nearest region. Let's say Hong Kong. Okay, and for the Malaysia people, you take a look on Singapore, maybe. Every hour, you pay for any SHA. If you create 10 SHA, then this is 10 times. Okay, so you can do some calculation. And not just the SHA hour, but also when you upload those data, you have a cost on that. Okay, but later on we have a module talking about all the costing. All right, but actually we need to refer to the pricing. Every SHA you create, you got more throughput, but you pay more. All right, and then here you got the agent, you got the producer library, ingress the data into the data stream. One thing we need to mention is you have your record. We call it user record here, or in other words, this is just the data block. Okay, the data that you want to ingress into AWS, and then in order to insert those data, you need to have the stream name. Okay, the data stream, the name, and you also need the partition key. All right, let's say we have 3 SHA. The partition key 1 go to this SHA, partition key 2 go to another SHA, partition 3 go to another SHA. Okay, so after the data is ingress into data stream, we have 3 things. One is the partition key. Okay, partition key identify where which SHA you go to, and then you have the sequence ID. Okay, the sequence ID will be generated. Okay, after you ingress those data. All right, I will show you the look and feel a little bit later. And then you also have your data block. Okay, for the data block, actually is your user record. Okay, and this is what we call stream record. The stream record must contain partition key, sequence ID, and then the data block. Okay, so that we can identify where is the record. Okay, is it in this SHA, that SHA, inside one SHA? What is the sequence ID in order to identify the record? Normally, the record just stored in the Kinesis stream for a few seconds, and then after you consume, all right, and then we move those records in the stream, and then because it is processed, we add together to S3, Redshift, something like that. All right, this is how we interact with the data stream. So one example is like this. Let's take a look. Suppose you got 4 producer. All right, you may have a lot of producer. Even if the mobile device, you got thousands, millions of mobile device installed have the library, have the agent. Okay, now suppose we got only 4 producer. Okay, we got different color, different number. All right, ingress into the data stream. All right, let's say you use this partition key. Suppose red or blue go to SHA-A. But by default, you got only 1 SHA. You can put all the data in a single SHA, but you have limited throughput. All right, now let's say I have 2 meg per second ingress, so I need 2 SHA, and I use the partition key red and blue go to SHA-A. And then green and purple go to SHA-B. Okay, so we have the data here, and the data here by default will be stored for 1 day. 1 day is super long, super enough. Normally, within seconds, we consume the data and delete those data from the SHA. Okay, but you can extend the 1 day to 7 days. All right, but of course, it increases the cost. Okay, by default, the data keep inside the SHA for 24 hours for you to process. All right, and it is according to the order. All right, suppose you ingress 1, 2, 3, 4, and then it will have the order persist 1, 2, 3, 4, and this one is 9, 8, 7, 6, 9, 8, 7, 6. Okay, you have the order, and you have the downstream application to process the data. All right, let's say I have 2 EC2 instances, or Lambda function, or container service, or EMR. Okay, suppose this application go to this SHA, all right, go to the first partition, the first SHA to process the data. And then you do something. Let's say we just count. We got 4 record, 4 blue record. Or you can do some other process. Let's say, let's count the sum. All right, I got 1, 2, 3, 4. So red is equals to 10. And then here is equal to 9 times 9 plus 8 plus 7 plus 6. It depends on how you process your data. It is your choice. All right, but the key point is from you ingress the data, and then they categorize your data, and then you can start process your data. It's just less than a second, or 1 or 2 seconds. Okay, so you can start analyzing all those data. It's very real time. That's the reason of using Kinesis data stream. Okay, so in order to process the data, this is the stream. Suppose you got more budget, you got more throughput, you have a lot of SHA, and this SHA you can use auto scaling. Auto scaling. Suppose I got more and more data going into my data stream, I scale out, and then less data at night, I scale in. Okay, to save the cost. We have auto scaling features inside data stream, and then your downstream get the record to process. All right, and then downstream we use the client library. Okay, so that each worker connect to 1 SHA, and then you can do your job. Maybe aggregate, maybe count, maybe sum, maybe whatever, massage the data. We support structured and also unstructured data. All right, we have checkpoint. Suppose everything fail, we don't need to do everything from the beginning. So there are many methods inside the client library. Okay, but if you just do a little bit things like this, you can use connector library. Connector library is a subset of client library. We just do 4 things. We can just do 4 things. Okay, client library is much more powerful. We can do, I think, around 30 things inside that library. If you just want to transform, filter, buffer, emit, means move the surface, move the data to other surface. If you just do these 4 things, then you can use the subset, the limited version, the connector library. All right. So the key difference between the file host and delivery stream is that the data stream is sub-second, less than 1 second latence. But you need to build, you need to write your application. Okay, no matter Lambda, EC2, or write in container. But for the file host, okay, 0 I mean you don't need to write application. It moves your data, but the latency is a little bit higher. Okay, but under the cover, the file host use the data stream. All right, we can move to any support destination. Nowadays, we can still do a little bit transformation inside file host by using Lambda function. All right, so that's the scenario. For data stream, let me show you how to create. It's just very easy. If you just go to the data stream, and then you see only a single page. Okay, the stream name, and then how many SHA do you want? All right, this is just estimate. Suppose you got 500,000 record. Okay, then it calculate how many SHA, but actually you type how many SHA do you want. All right, and then I got some screen capture that show you the look and feel. Let's say I use command line to, let me just post it to the Slack group. This is the Slack group. Some screen capture from previous training. All right. I think that's enough. Okay. So yeah, let me talk a little bit more and then we will have the lunch together with the lab. So after you create a stream, let's say the stream is called, let me get back my pen, IoT demo. You create the IoT demo. You can use the PODIFS library. You can use the agent if this is Linux machine. You can use command line. You can use SDK. A lot of method to put those stream data. And this is command line, AWS, Kinesis. All right, put record. Put record means put a single record. Okay, you can use another API call put records. Okay, means more than one record. All right, say for example, I want to group 5 records together so that one API call to put all those data. Okay, this is kind of aggregation and collection. So summarize the data before we move back to AWS. So the stream name is IoT demo. As we mentioned, a stream record should have partition key. Okay, you specify the partition key, and then this is the block, the data payload. All right. Let's say I have sensor ID, temperature. This is IoT device related to anything deal with the temperature. Suppose is 30 degrees or more, then we turn on the aircon automatically, something like that. Status okay, and then after you insert those records, you will get the SHA ID and then the sequential number. Okay, so a stream record must have partition key and then the data block and then also the sequential number. Okay, the sequence number identify your record inside the SHA. All right, and because I've got only one SHA, I have the SHA ID the same. Suppose you got more and more SHA, maybe this is SHA-1, SHA-2, SHA-3, and how you ingress those data in different SHA based on the primary key and based on your PODIFS library. All right, so here we just ingress 3 record. And how you are going to consume, it really depends on your application. Let's say here, I just select the data, okay? So just like this. Yeah, by using the client library or the connector library, okay, here I just display using another command line, okay, and then in the stream, get from this SHA ID, and then what data you want to get, okay, you can specify. Now I say trim horizon, you can get all the data from the beginning, from a timestamp, from the last unprocessed data, all right? And then after that, you get record, and type this SHA irritator, and then you can see the record like this. Okay, so here is just an example showing that inside the SHA we have this partition key. Okay, and all the data block, all the sequence number. All right. So if you want to take a look, it helps you to process your data. The Kinesis data stream before I use Trains Horizon. Okay, starting position. Let me put this once again into the Slack group. And then you can, based on time saying, I just want to get the record from 3 p.m. All right, based on sequence number, trim record, trim horizon means the last untrimmed means unprocessed data. All right, so this is related to your client library. All right, so this is related to Kinesis data stream. It is already 12:30. Do you have any questions before we go to lunch? Let me take a look on the chat. Let me take a look on the Slack. Anybody got any questions? Okay, so one question, I want to make sure that everybody see this purple color, right? The lab. Anyone didn't see the purple color? And what we are going to do now is we are going to have 1 hour lunch and 45 minutes lab. All right. I make it more flexible so that you can do lab first, because some of you may have lunch 12:30, some of you 1 o'clock, 1:30, whatever. Okay, so 1 hour lunch and 45 minutes lab. So we come back at 2:15. Is that okay, everybody? Okay, not just lunch time, but also lab time. Am I correct? Okay. Is that okay, everybody? 1 hour lunch and 45 minutes lab. If you got anything related to the lab you failed to do, you can always ask in Slack. I can come back quickly because I'm just at home. Is that okay, everybody? Let me just ask a few people. Is that okay to you, Horace, Kelvin, Kathy, Gideon, Eric? Okay. Yeah. So, thank you. Yeah, let's have the lunch and lab. Thanks, Darren. Roger, you didn't see your tutorial, means the ebook, or didn't. If you finish, then you can go to have lunch and do the lab. But Roger, you didn't see the tutorial in your account. What does that mean? Means you cannot see the lab or you cannot see the ebook. Roger, are you here? Roger, cannot see the lab. So I need to modify for you. Because I add all the lab based on the register email that you provide. For Roger, which first of all, Roger, which company are you from? I need to. Okay, and that means PC stuff. Are you replacing somebody that I remove the previous one? I got all this information because your company register force it. If anybody change, I need to delete the previous one and then add you in. Do you know which one you replace? Anyway, you give me your email address once again. I add you in, and I verify with some other people. Okay, so you use this email to register the lab account. Can you see the lab now? Okay, good. So anybody cannot see the lab, just let me know. All right. Once again, 1 hour lunch to and 45 minutes lab to 2:15. Okay. Anything, please ask in Slack. Okay, Darren. So you solve the problem or
Yes, soft.
solve? Okay. And then yeah, keep going. Anything solve, and then I delete those message so that we don't get confused. Okay, I see you a little bit later. I will be here anytime if you Slack me. Kathy, I add you to the lab. See, not here. Kathy, I just add you into the lab. Can you see the lab? You need to create an account using your company email, the lab account in aws.quicklab.com. Make sure that you see the lab. Can you see the lab, Kathy? Connect stream button. This is Firehose, right? Okay, let me just check the latest console. Oh, I know. Because they got new features, by default, they are not using SQL.
Ayah. I
Okay.
can delete it. Is it? I created using the Flink.
Yeah. Frank is very new, so that they may not update the console. We should use SQL instead. Okay, sorry about that. I will report, but they will not change until next week. Okay, so using the legacy, you okay with that, Karen?
You quickly try now.
Okay, and then after you click create application, and the data source, you should be able to browse the data stream. Okay, here. Is that okay? Yeah, a little bit change in the UI. So Kathy, can you see the lab now? So Darren, are you okay with that? The lab now?
I'm doing.
Okay. So anything, just ask in Slack.
Problem about the schema discovery failed.
Okay, it is 2:15, and first of all, can you hear me? Can you give me some?
Yes.
Yeah, thank you very much. Before we have lunch break and the lab, we are now in the middle of module 3, Kinesis real-time data, and many of you already finished lab 1. For those who didn't finish, you can do it later, maybe after class or at the end of my section. Okay, so today we will take a look on around 5 module, 5 or 6 depends. So let's keep moving. Before, when you are doing the lab, we find that there is some changes to the lab step. Likely, it is often the case that AWS changed something. Like this time, we have new features, and then that's why originally default we use SQL statement to query using the Kinesis application, and now the default changed to Flink, and then that's why we need to select legacy SQL. This is not in the lab step because it's the change is quite new. No one reported that before, and we face it, and I will report it later. But it will not change until we can. All right, that's often the case. Yeah. So let's take a look of the remaining of this module. So next is Kinesis video stream, actually likely for the camera. All right, nowadays a lot of camera in your industry, in your city, in your home, in the drone, and then also yeah, a lot area. Think about nowadays some car without the driver, they use the camera to identify and drive automatically. So this is also the use case of Kinesis video stream, and because of the pandemic, COVID-19, a lot of building at their lobby using some thermal imaging. So to see who has got fever when they enter the building. It's just, I think you all should already see this, okay, in many building entrance, see whether anybody got fever, all right, like this. So increasing demand of the video stream, that's why AWS produced this solution to them, the live video, and we can set alert. And some other company, not company, other country, they can use this to find automatically is the play in their car, is it a weather car, is there any crimes related to them? So this is also some use case related to Kinesis delivery, the video stream. Okay, maybe not just for the profit or cost, but yeah, find related to safety, healthy, or crime investigation as well. So Kinesis video stream, normally, once again, we need the stream and then the application. Okay, maybe you use still EC2 or Lambda function or some container application, okay, to process those video, okay, and then set the alert. All right, normally you got some video media, all right, maybe from camera, maybe from some phone or some internet things, all right, so that we can do something to process those data. So in your lab, you work with the Kinesis data analytic, all right. At first, this is just like other consumer, all right. It will be easier for you to use SQL statement to query those stream data, all right. So by using SQL statement, but now it is legacy because we can integrate it with Flink, and also there is a Stream Studio. Okay, 2 months ago they announced this news, so we cannot find any information inside the PowerPoint because it's quite new. And then we connect this application, this analytic, to either the file host delivery stream or data stream, okay, so that it will be easier for you to write your application. You may not need EC2 instance, you may not need a Lambda function. As long as you're familiar with SQL statement, just like in the lab, you can interact with the stream data, okay? And then do something, notify the admin if something abnormal, reporting, whatever. So this is data analytic, okay? So as you can see, connect to the data stream or file stream and write a SQL statement. And I can show you how it looks like in my previous demo. Let me go back to my Google Chrome first. Okay, this is it my Google Chrome? Okay, let me log in first. My Google Chrome is here. So if I log in back to my console, before the lunch, I have already created a file host stream, and then inside the delivery analytic. Okay. Now there is something new. This is really new, just around 2 months. The studio, you can create a notebook, just like the Jupyter notebook. Okay, so that you can use it to your development, all right? Or for legacy, okay, you go back here, we use legacy SQL. Okay, this is in our lab 1, we need to select this. Okay, and now we can integrate it with the Apache Flink. And say, for example, this is my app 1, and then we create a application. Okay, and then we can connect the source. Let's go back here. The source is here. All right. This is all the information related to the data analytic. And if you connect, now I have the file host stream. Before in your lab, you connect to, once again, another file host. And then you can use Lambda function to do some pre-processing. And what permission you need in order to interact with those stream data. Okay, you may also save the final result into S3 DynamoDB. So you need permission. So here, select the permission. And now let me discover, maybe after the lunch break, the demo data already stopped. Let me go back to this one and then start stream the demo data. And now a few seconds, really, you see, you can discover the schema. All right, this is some demo data. Okay, as long as, this is no problem, I save this schema. Okay, and then you can start writing the SQL statement, just like here in the real-time analytic. And then, of course, you need to create a table. What are the data type, integer, character, and then you can start using those select, where from, to query those data. And destination, we can save the result to somewhere else. All right. So in your lab, you will interact with data analytic. Okay, quite easy. You can process your stream data. All right. So this is data analytic. Nowadays, they support Flink and also Studio Notebook. All right, some new features, not just SQL statement. Okay, so you select the source, likely the source from Kinesis data stream or file host delivery stream. Okay, not just SQL statement nowadays. And then continuous deliver process data. I want to save it into Redshift, say for example, or S3 after you finish those process, how you're going to save in the destination. So the data source, as I mentioned, likely file host and data stream. We support a wide range of format. Okay, not just JSON, but CSV, variable column, unstructured text. So you can also reference S3 as data source, join together those tables. So using SQL statement and then do the analytic. But the drawback is that it is not so flexible, all right? Because comparing with your Python, Java application, it is much more flexible, a much more rich customization, okay? SQL statement likely just insert, update, delete, select, join, aggregation, something like that. So continuous deliver the process. The destination, once again, we support S3, Redshift, Elasticsearch, and then you can integrate with Lambda function. By using that together with data stream, we can make it sub-second, less than a second, the process is very real time, nearly real time. So some use case, just like in our lab, ClickStream, I want to immediately analyze the customer, the user, how they interact with your mobile application, say for example. So we have the file host to deliver to those support destination. But here, I want to take a look and query those stream data in real time using SQL statement or Flink or some other supported notebook application. All right. So this is all from AWS to process stream data. Okay, file host, data stream, video stream, and data analytic. And of course, you can use some third party, integrated with third party. In our module 10, we will talk about Spark, but inside Spark, we can run a lot of things. Memory together with this, we can also have ML, machine learning. We can also have Spark Stream. But in our module 10, we will go into much more details. We also support those stream data, but actually under the cover, they are micro batch, all right, micro batch to process those stream data. We support a wide range of format, structure, unstructured, and then batch processing or stream processing. You can also integrate with some of you already working with Kafka from or some other supported format. Okay. Sorry, I clicked something wrong. Okay. Okay, my monitor come back. Sorry about that. Okay, so let's move on. So some of you already use Kafka. The key concept in the next civil slide is that you can still use your third-party tools. Okay, means not AWS tools. Say for example, I still want to use Kafka. It is possible to do so. You may integrate this in EC2, work with the AWS. You can use Kafka Stream, use their Connect, use their tools. It is possible to do so. All right, and then maybe at the end we move all those data to say for example EMR. All right, in our module 6, if you're happy, you can still use those Apache, from Storm, SAMC, something like that. There are many stream processing tools. And now Flink is integrated with I should say that AWS integrated Apache Flink inside the Kinesis data analytic. All right, so you don't necessarily run it on EMR, run it on EC2. If you're using Kinesis data analytic, you can choose this, and this is the default runtime, okay, apart from the SQL legacy. All right, so yeah, you still can use third party. That's the key message. Okay, but by using third party, maybe you need to take a look on the documentation provided by third party. Okay, may not inside just in the AWS documentation. So here, suppose your application, you may have social media like, tweet, share, something like that. You got some click stream. Okay, I want to save a copy, the raw data lake in the S3 first. All right, original data, and then we might archive in Glacier. Okay, so that we keep all the original data, and then to save the cost, move to Glacier. And then we may also have another Kinesis data stream, and we have the application. No matter you use EC2 Lambda function or containerized application or Kinesis data analytic, okay, Flink, SQL statement, so that you process the data. After you process the data, maybe you save in S3 another bucket. Those data are processed, aggregated, okay? And then we keep append to Redshift, this keeping our historical data, all right? And become bigger and bigger, the database. And then we have a dashboard. Maybe you can use QuickSight, Tableau, Power BI, or some other tools, application to do this. And then you may also have another app to process. Maybe here we just use EC2 instance. Take a look on the trend, okay? So what should we do next, okay? And focus. This is just some social media analytic, okay? So for use case, once again, in the AWS case study, there is a case related to Snowflow analytic. It's real-time analyze about some financial data, all right? So the key surface, they use Kinesis, EC2, S3, and likely the result, like many companies, they store in Redshift. And then the scenario will be what was something like this. This is a past case. They get the EC2, collect all those stream data, and then use Kinesis stream, data stream. Okay, the raw stream they deliver to S3, and then we connect, we process the data for the raw stream, do some enrichment, all right, enhancement, and then after another delivery stream, use another application, okay, to process and save those aggregated data to Redshift. For bad data, we just put it into other stream. Okay, so the key point here is that they use a lot of AWS servers and some third party like Kafka, all right, but inside AWS, use data stream, use table stream, the DynamoDB table, okay, and then SQS, SNS, so to make everything much faster, all right, much more reliable. So this is all the choice related to stream data, okay? So if you want, it depends on which one is your concern. If you want AWS managed, it means that I don't need to maintain the OS, the update, configuration, all right? And then you use the AWS managed things. If you still use Kafka, all right, this is not AWS managed. You are going to provision, update, maybe not only the OS, but also the application version, okay? But AWS manage, AWS handle all the availability, scalability, and maintenance, all right? So we can use queue service, okay? If the order is important to you, you can use FIFO queue. If not important, the order, but I want unlimited throughput, then you may consider SQS. And then for other order consideration, by using Kinesis stream and DynamoDB stream, also here we guarantee the order. Okay, Firehose doesn't guarantee the order. Okay, and you also take a look on are those technology at least once or except one. Okay, at least one, it means that you may have the data duplicated, all right, so that you may need some sequence ID in order to avoid double processing. Okay, exact one, you can choose SQS, FIFO queue, or DynamoDB stream. Okay, DynamoDB stream is just inside DynamoDB. You can enable the stream so that all the changes you can have an endpoint connect to those stream and start processing those data. And the data retention period, okay, if you're using Kinesis data stream, this is 7 days. Some other support 14 days. But if you do it in Kafka, you config yourself, all right? And for most managed service, you have your data distributed across 3 availability zones. So it is highly available. But for Kafka, you do it yourself, all right? By using this 4, there is no limit. But if you're using FIFO-Q, at most, every single second, there is only 300 message supported, okay? For parallel consumption, data stream and Kinesis stream is your choice. Parallel processing, all right? And then if you have the stream map reduced, then you use, once again, the data stream and Kinesis stream. And we support 1 meg size, as we mentioned before. Here, only 400K, and then the SQS message only 256 KB. Okay, so this is the consideration when you select, and the cost from low to high. Yeah, so this is you also need to consider the cost. Okay, so how we choose those storage for the stream data. Okay, and for stream processor, what should you choose? We think about, are we going to use AWS Manage, the size, the cost, is it fault tolerance? It means something failed, recover automatically. If you do it in third party, you may need to handle that as well. All right, do we need the data according to the order? What language are we going to use? Are we going to use SQL, Java, Python, or some other programming language? Okay, so we consider all this in order to select the stream processor. It means the application. So you can use EMR. EMR we will discuss in module 6, and Spark. Okay, module 10. Inside EMR, we can run a lot of applications. Spark is just one of them. If you do this, the Spark streaming inside EMR, this is AWS Managed, all right? However, if you use EC2, it means unmanaged. You use the kind library, you configure yourself. But if you use the Kinesis data stream, Lambda function, AWS Managed. If you use third party, okay, the client application for processing those streams using Storm, okay, of course, you configure yourself. Okay, what does that mean by serverless? It means to you, you don't need to handle the availability, scalability, and almost no provision time for you. Okay, because if you're using EC2, okay, you still have some server, some virtual machine. EMR, under the cover, they still use EC2. However, Lambda function and the data analytic is totally to you is serverless. All right. After a few clicks, you will have the data, the application, the tools ready. Okay. No provision time. No need to handle everything under the cover. All right. So once again, depends on the throughput, and then are they multi-AC? One thing we need to consider, if you're running EMR, it is a single ASAT architecture. It means that if one availability zone, you can think about availability zone is just like the data center. All right. One availability zone may contain one or more data center. All right. But they locate so close that if one earthquake, fire, tsunami, or a typhoon, maybe all the data center, all the availability zone may go down. So think about availability. But consider this, EMR, even if it is a single ASAT binding, all right? But this is a compute resources. Okay, after we compute, we recommend to terminate the whole cluster so that your data still safe in S3, DynamoDB, RDS. For your data, it is highly available. Any data in S3 already across 3 ASAT. any data in DynamoDB is already across the AZ. Any data in RDS, if you have multiple AC deployment, you have another copy in another AZ. The most important thing is we don't lose our data. We just lose those compute resources, okay? So this is the consideration. By using EML, likely you use Python, Java, Scala, all right? But once we mentioned data analytic, SQL statement, but nowadays we support Flink and Lambda function. You can use some other like Node.js, Go. So it may the C#, the .NET. So it may affect your decision. I am a Windows guy. I want to use .NET. Okay, so here, all right. So a multi-stage process, we can do a lot of tasks inside EML. But for Lambda function, likely we trigger the function based on event, and then some of them is just single stage processing. One time, you may need another EC2 for another processing, okay? So reliability, we have checkpoint, and then the Kai library maintain the reliability. The job fail, the task fail, we have resume, we have the failover, all right? And if you're using AWS, the AWS handle all those things, and Lambda function is fully managed. But if you use a third party, likely you are going to configure the availability, manage yourself. So this is just some stream processor, okay, your application, which you are going to use. Okay, Lambda function in EC2, EML, or third party. So for stream collection, you can use also AWS service. You can use EML to process, and then Kai library install in your EC2 instance, or even on-prem Lambda function. Okay, and then third party. Okay, this is likely the big data Apache ecosystem. So this module, mainly we focus on the stream data. And then let's take a look on the answer. The Kinesis data stream, yeah, we have the shards. Yeah, what is the shards? It's basically the unit that related to the throughput, and then identify with the partition. Okay, so every single shard is 1 megabyte write, and then per second 2 megabyte read data. If you have a higher throughput, you can create more shard, but of course it charges you more. All right, it's based on the partition key to insert those data into those shard. And by using Kinesis to analyze those big data, we can have very high throughput as long as you create more and more shard. And then you don't need to handle the administration scalability, but it is still very low cost, very real time. Okay, less than a second, you can have your data ready to be processed. And then Kinesis, is it good for large data file? No, every single file, 1 megabyte. All right, if you have a huge file, it is not good to use Kinesis family. All right, instead, a large volume of small file, that's the best situation of using Kinesis family. So lab one, some of you already, many of you already finished it. Yeah, for those who didn't, yeah, you can do it later, maybe at night also. So the lab focus, it is just a warm-up lab that you play with the Kinesis family. They already have the data stream. You create the analytic. Remember here in the Slack channel, select the SQL legacy. All right, that's the most important. Okay, and then we still use the SQL editor. You just copy and paste basically those SQL statements, create a table, and then how you are going to interact with those data. Select statement, insert statement. All right, and then you create a file host stream, and then at the end, you save the result stream back to S3. Okay, using the data file host. So here we just process the social media, the Apache log, and then do some transformation in data analytic, and then deliver the result to S3. Okay, just you don't need to configure the API gateway and the data stream. It's already there. If you're interested, you can go there and take a look. But mainly for the lab is focused on the file host, data analytic, and save your result to S3. Okay, so this is the lab 1. Okay, see if you have question. If no, then we keep going. Just make sure that everybody can see the lab, participate in the Slack channel. And one thing I need to talk about is that please register to the class. Wait. At the end of Wednesday, you will receive a certification, attendance cert. All right. But in order to do that, you need to register first. Okay. You should receive an email from AWS Beijing. All right. AWS Education CN. And then there is a registration link. So you register using your company mail. If you use personal mail, it is all right, but you need to tell me. I need to report to AWS Beijing, and then stay in this training, the WeChat, the WebEx for 67% of the time, and then at the end you will get the certification. Okay, so please do the registration. Okay, but after you do the registration, at the end, the attendance cert, you can change the name. It means that suppose my name is Chen Taimin, you can change to Peter Chen. Yeah, for you to get this proof that you attend this training. All right. Anybody got questions? Okay, let's keep going. If you got question, please ask in the channel. Please don't send me direct message because I got more than 2,000 students. I don't really take a look on the direct message. Just send in the channel, please. Okay, let's keep going. Module 4 is related to data storage. Okay, I drop it down first for your registration. Okay, that's okay. I will notify the administrator. Okay, let's keep going. Module 4, we don't have lab, but next module, module 5, we have a lab on that. Okay, related to Athena. Some of you already familiar with Athena, but it doesn't matter. You can still try to see what you can find more in the lab environment. So this module related to the storage. Okay, as we said in the big data pipeline, we have the data ingress, collect, or inject into our pipeline, and then we store. Actually, Kinesis data stream is a storage service just for storing the stream data for a few seconds. Okay, but default is 1 day, at most is 7 days. After you store, they categorize, and then you start process. So we break it down, storage process, decouple. Okay, so this module, we take a look on the storage solution. AWS got a lot of storage solution. So once again, last two module, module 2 and 3, we take a look on the ingress. Okay, you can move the data using command line, multi-path upload, slow BOSS, slow mobile, through the VPN, Kinesis family, okay, or third-party tools. So after you ingress those data, we store in the storage. Okay, so here, this module, we focus on storage. Okay, so here, the key point is use the right tools, use the right service to store the data. Okay, different tools for different purpose. Okay, do not try to store everything in relational database. Okay, and I can tell you a story. Maybe 15, 20 years before, Amazon just store everything in relational database. Okay, and at first they use Oracle. Now they use their own different database for different purpose. Okay, do not store everything in a single location. Okay, because you may have some data unstructured. You may have some key value. For key value, likely you can choose DynamoDB or the Elasticache, even Redis. Okay, some of them you still need compact query. For those, likely you can still store in relational database. We got transactional data, analytic data. We may consider Redshift. Okay, but for unstructured data, where should we store? We cannot store in relational database. We can store in S3. We can store the semi-structure, maybe in DynamoDB, depends. So the key point is use the right storage for your project. Okay, so if those are general object storage, unstructured data, you can store in S3, and then to save the cost for your raw data, okay, you can go to Glacier. Okay, for Glacier, it could be much cheaper than S3. Can be 10 times the difference. Okay, if you store here $10,000 every month, maybe here less than 1,000, and then you can store the data. All right, and then EFS, if you need some shared storage. EBS is just disk drive. This is not shared by default. All right, just one instance mount to the storage. Likely for EMR, they use EBS by default. Okay, but we will talk about EMR later. And then, of course, in EMR, Hadoop cluster, you can save in the Hadoop file system. All right, just you have multi-node, store the data inside. But once again, in AWS, we recommend decouple so that we don't store data here, so that in the low season, in the nighttime, you can terminate after you finish processing. Okay, once again, we might just process 4 or 5 hours a day. The remaining 19, 20 hours, I just terminate those cluster. Okay, to save cost. For search, we can use open source Elasticsearch or AWS, the cloud search. And then for the cache data, NoSQL, you can use NoSQL in memory, that's Elasticache, or NoSQL on SSD. All right, key value pair document. That's the perfect case of using the DynamoDB. Relational data, we may save in RDS if they are OLTP, online transactional processing. But for OLAP, it is better for us to save in Redshift. And then graph database. Okay, so here is that we got more than 10 type of storage. Okay, managed solution. So find the right place to store your data. Is it key value? Is it relational database? Is it NoSQL? Or is it distributed storage? So first of all, with the terms data lake, central repository, we keep our raw data. Okay, or in other words, we defer the data processing. Okay, after we get the data, we store somewhere first. Okay, and then we start processing. But maybe today we process using this method. A few months later, we may have some other new method to process same original data. So we keep all those original data. That's what we say the data lake. Okay. For data lake, actually we have a centralized location to keep our raw source data. Okay. So by using that, we don't know the schema yet. Okay. Maybe we don't know how to process the data yet. Okay. So we defer this process. And then we may perform ad hoc query. All right. Just many of you use Athena query those centralized data. And then for those data lake, the most important is scalable and distributed. All right. So that yeah, we can scale to billions of files or a terabyte of data, exabyte of data. We decouple the compute and the storage resources. Okay, so that's the data lake. In an example, in this diagram, data lake simply means the data is unprocessed. Think about the water in a reservoir. We might not be able to drink directly. All right. So data warehouse is just the data is processed. They are very structured. Okay, just like the water is already streamed, is already at the material, whatever. This is processed. Okay, unprocessed and processed data. And if you take a look in the IT world, normally for the data lake, we apply the schema when we read the data. We defer, okay? But data warehouse, when we write the data, we need to know the schema, okay? Just like the traditional relational database, the table. Here is ID, here is the name, the date, and then the name, all right? In the column date, you cannot insert some other value. We need to understand the schema so that we can write the data, okay? Schema on write, okay? So here could be structure, semi-structure, unstructured data. And for data warehouse, likely we only have structured data. They are very structured, okay? This side, we use SQL statement, okay? We can aggregate some average count using the SQL statement. And here in data lake, it is very flexible, okay? This is just sample repository. Maybe our marketing, HR, sales application connect to same data. Maybe the EMR get those data to process, and then your Redshift also get those same data. You have ad hoc Athena query. Okay, so to have multi-application process the same data. All right, so it is highly recommended to use S3 as the data lake because the features provided by S3 are very cheap, very fast, parallel processing, and then very durable. All right, so here you can use EMR to get the data to process. Redshift, all right, Kinesis, and then Glue, RDS, a lot of other AWS service can integrate with S3. And in our normal architecting training and the technical essential training, we talk about the benefit of S3. Yeah, like every data stored in S3 is at least 3 copies across AZ. That's why it's super durable. And then S3, the SLA is 4 line, 99.99%. Okay, in a year, maybe just a few minutes, you cannot use. After a retry, then you should be able to get your data. And it is very high performance. You can have parallel process. Some of you interested in Redshift, I can tell you that the best way to load data into Redshift is using S3 copy command. Because by using this command, they automatically, okay, run parallel processing. Okay, maybe 10, 100 thread load the data into Redshift. It's super fast. Okay, very easy to use. You can use the console, the command line, SDK interact with S3. Super scalable. All right, you can put exabyte of data into S3 and integrate it with a lot of AWS service, like the KMS for encryption. Your EC2 can get those data. Your Kinesis file host can stream the data into S3. Okay, integrated with most of the AWS service. And then to keep your all raw data extremely low cost, you can put it in place here. Okay, in US region, what will they say is basically $1 you can upload, store 1 terabyte of data. You cannot buy a hard disk using this amount. In Hong Kong, it's just $2 for 1 terabyte of data. And it is already, you got at least 3 copies, all right? And very cheap, very durable, okay? And for unstructured data, think about all the log file, okay? Think about all the stream file, all the file format, all right? And then, yeah, S3 for data lake, And then next one is, suppose you got NoSQL, non-relational, all right? Our data is not very structured. Think about some hotel, the people, they just upload, fill the comment, all right? This is not structured, all right? Schemaless. And then one thing I need to talk about the consistency. There is a very big change here. Because say for example, S3, they are distributed storage, S3. And DynamoDB, SQS, they are also DynamoDB. Okay, we got multiple AC. So suppose you upload a file. In S3, in DynamoDB also, you got at least 3 copies across the AZ. Okay, so originally, S3, DynamoDB, they are all eventual consistent. What does that mean? Okay, so suppose this is the data 0. I change to 1, maybe at the same time. Okay, some application get the data from this AZ. Some other application, user, customer, wherever, all right, get the data from here. So here, you change something, it takes some time to replicate this data to other AZ. Normally, it's less than 1 second, okay, maybe just 10 milliseconds, okay, or 5 milliseconds, okay, very fast. But if you come almost immediately your application, it is possible that you still read the old data, okay, the 0 rather than 1, okay. So this is the eventual consistent. We have been talking about this for 14 years, all right. But one big change for S3 is that last year, December, this is really a big change, impact everybody. I need to find the documentation. S3 consistency, strong consistency. Okay. Let me find the announcement. It's just less than a year. It's really big change, but this is a good change. Let me post it into Slack. Okay, here. Yeah, last year, December, S3 now is strong consistency. So it means that no matter anybody, right, you will read the latest data, no additional cost. Okay, so it means that you don't need to care about this. Okay, every time you read data, it's the latest. Okay, it is no longer eventual consistency. Okay, but for DynamoDB, still eventual consistent. Hopefully, someday later we change to strong consistency. Okay, but at the moment, DynamoDB still eventual consistent. Okay, we are talking about NoSQL. Once again, DynamoDB is a distributed storage. When you change something, yeah, it takes some time, 5 milliseconds, 10 milliseconds, okay, to replicate. Maybe other application will read the old data, dirty read. Okay, but what you can do is, when you read those DynamoDB data, you can specify strong read consistency. Okay, you can specify, but if you don't specify, you may possible read some old data, dirty read. Okay, eventually consistent means eventually, maybe after a few 1 second after you refresh, you can see the latest data. Or when you read, you can specify strong read consistency. Okay, the consideration is that it use a double bandwidth. Okay, double read capacity unit. Okay, so the cost will be higher by using strong consistency. Okay, so DynamoDB NoSQL is schemaless. Default is eventual consistency. You can use strong consistency. It's distributed storage. because it is distributed storage, it is horizontal scale. All right. So if you got some NoSQL key value section data, they're perfect storing in the NoSQL. By talking about this storage, we think about, are we storing relational data or are we storing non-relational or NoSQL? Okay, this is a fixed schema. All right, we have to understand the schema before we write data. Schema on write, and here is flexible. Okay, so you don't have fixed schema. And here we have the exit and no exit compliance. Okay, optimized for compute, optimized for storage. For relational database, we actually scale up by using, say, for example, RDS. You can scale up the instance, but the data still living inside the same box. But for DynamoDB, actually, horizontal scale automatically, it is serverless to you. You don't need to care about that. Okay, but under the cover, they are distributed storage. So for non-relational database, what can we do? Think about columnized storage. Okay, for you to understand, we understand traditional database is row storage. Okay, record by record. Okay, say for example, this one is ID, name, and then dates, and then some other column. All right, so we store record by record horizontally, but columnized storage store the data like this. Let me get a very good example by actually Redshift columnized storage. If you're using Redshift, this is columnized storage. You cannot change. What's the difference? Let's take a look under the cover. Okay, so suppose here we got some record. Okay, just like Amazon, they are selling books, something like that. Just here, we have the ID, name, age, maybe your customer, maybe your patient, maybe your whatever employee. Okay, so we store the data in the database like this. Okay, so one record, and then another record, and then another record. Okay, this is row-based storage. Row-based storage is perfect for online transactional processing. Think about this is a bank and ATM machine. Okay, maybe at the same time, your customer, thousands, millions of customers go to the ATM machine, insert the credit card or the ATM card, and then insert the password, and then check the balance. Actually, this is select statement. So you got millions of customers going into your database. We need to, based on the card and identify the record, show you the current balance. So we focus on now. And then suppose this customer draw $100. All right. So this is a update statement. Okay, update the balance to reduce $100. Okay, a lot of insert, update, delete, something like that. So this role-based processing is perfect. I can quickly identify your record and then update the balance. So just run block. In many databases, the block could be 4K, 2K, 8K. Okay, and then finish the task, the job. However, it is not good for analytic. All right, analytic, we talk about online analytic processing. Okay, suppose I want to find the state, the country. I want to find our customer, how many people in America, China, US, UK, wherever. Okay, so you need to get all the record, all the block, and then filter out that you don't want. Okay, so this is not good for analytic. But for column-line storage, actually they store the data like this. Let's go down a little bit. Okay, so if you take a look here, instead of storing row by row, they store all the SSN like the ID first. Suppose you got thousands, millions of records. So this one here, and this one here is the same. And maybe the fourth record is this one, fifth record is this one, etc. All right. So in a single block, they store the SSN first, the ID. Maybe we got another block for name, some other block for age, some other block for address, something like that for country, city, street, state, whatever. All right. So for this, it is not good for transactional processing. Okay, it is good for OLAP. Why? Suppose somebody want to change the city, change something. One block we cannot finish. Unlike the previous example, we might need to get the ID, oh, this guy, and then get the city, telephone number, and change. We need multi-block in order to do the same job. Okay, but it is very good for analyze. Maybe I just want to find all the country, how much number. So 2 or 3 block, and then you finish your task. Okay, so I want to say here is that OLAP is very good for analytic processing. Say for example, the bank scenario. How many customer their bank more than $1 million Hong Kong dollar, but didn't update for the past 24 months. All right, answer the question like this. If you're using transactional database, it is very hard to answer the question like this. But the OLAP is ready for that. So that's why column-line storage, okay, is very good for answering analytic question. Okay, Redshift by default is column-line storage, but if you're using open source format, Pacrete, ORC also are column-line storage. Okay, let's keep going. Okay, so as I mentioned before, column-line storage, this example is just similar to what I showed you in Redshift. Actually, they store the data like this, and then roll the record. Sorry, my monitor also got problem. Okay. My computer suddenly got some problem. Let me. Okay, come back now. All right, so here is that the column-line storage, we store all the single column first, and then email address, and then block. So comparing with the previous example, column-line storage for analytic, you have less block, scan less data in order to answer the question related to analytic. All right, but it is not good for a lot of insert, update, delete. Not good for transaction. Okay, so example, suppose you're using Cassandra, HBase, Redshift, Pacrete, ORC. These are some example for column-line storage. And then for the NoSQL, actually, say for example, we store the JSON, and then MongoDB, Cassandra, DynamoDB. These are some example for document DB. Inside AWS, now we got DocumentDB is compatible with MongoDB. So this is some choice. And of course, DynamoDB is a very good choice for storing document and key value. All right, we don't have fixed schema, and then it is very quick and also serverless. All right, this is not living inside VPC yet, and the data is on SSD. nowadays we support transaction. All right, that's the DynamoDB, and on-demand capacity for spiky traffic. So very durable and scalable, because every data you store in DynamoDB, you at least got 3 copy across the ASET. Okay, and then tightly integrated with EML. One key point here is that suppose our data is really living inside DynamoDB, and we use EML. How can we integrate those data? And the key point is using Hive. Okay, by using Hive, we can use SQL-like statement and then query those data, not just from S3, but also from our Hadoop file system, and also from DynamoDB. All right, using Hive, we can do something like that. Join DynamoDB together with S3 table. It is very powerful, even if those data is unstructured, semi-structured. Some of them in DynamoDB, we can use one job to integrate them together. All right. So this is later on we will talk about the EML, but here we can consider some of the data stored in the DynamoDB. Maybe the NoSQL, maybe just key value document. And then another database engine provided by AWS is called Labtune. Labtune is basically for graph database. Actually, a lot of social media, let's say for this example, use graph database. There is really a lot of relations. Vertices means the node. Okay, you can consider this the node. Let's say in a social media company, you have the people, and then they are friend. We are the suggest friend, and then we like the item, we give the star. All right, so there are many relations, and we call these relations as edge. Okay, so this one is edge, and this one is node. Okay, really thousands, hundreds, thousands of relations between all the nodes. Then it is a good case for using graph database. And in AWS, we can use Labtune to do this graph database. Okay, but if you are using Spark, GraphX is another choice. Okay, so this is just provided by AWS, the graph database. That's the Labtune. So some use case, drug discovery, fraud detection, social media, network security. All right, this is just some use case. For Labtune, actually, you can integrate it with S3, load data inside, and then perform those management to your graph database, graph data. So if you have something like this, then it is better for you to use this Labtune database. All right, graph database. Okay, a little bit more slide, then we will take a break at around 3:30. So if this is just in-memory key value store, we can consider those Elasticache. Okay, say for example, for DynamoDB, normally when you query those data, it is single-digit millisecond response. Suppose your EC2 talk to DynamoDB, yeah, it is very fast. Within single-digit millisecond, it is maybe 5, 8, 10 millisecond. You can get your response. But some company, especially the game financial company, they need much quicker response. Okay, 1 millisecond is not enough. They want microsecond. Okay, it means that maybe just 13 million second. I mean, the first that's the microsecond. Okay, so as I can tell you, 1 second equals to 1,000 millisecond, and then 1 millisecond equals to 1,000 microsecond. Okay, some financial company they really need that type of performance, very high throughput. And then in this case, they use ElastiCache, Redis, Memcache. ElastiCache, Redis, and Memcache is inside ElastiCache to produce this in-memory key value store. Because they are in memory, they are super fast. Okay, so these are the two open source engine. The difference is that Memcache is not persistent. Suppose any node failure, you may lose your data. But Redis is persistent because we got backup, we got highly available. Okay, some standby node. If the primary node goes down, we will have the node recover automatically. No admin administrations configuration. Okay, so by using Redis, it could be our N database. Okay, store the data persistently, even they're in memory. Very high performance, like the game, the leaderboard, like some financial data. They can also use this ElastiCache. For more case, you can go to case study and take a look who use the ElastiCache. All right. Another storage, this whole module we are talking about storage is Redshift. Okay, Redshift is basically a very huge database. We have one module talking about Redshift. It is petabyte compatible, and nowadays it is exabyte compatible because we can offload some data back to S3. Okay, so that not just petabyte, it is exabyte. It is a data warehouse, as I mentioned, columnar storage, and they are using MPP. MPP, massively parallel processing, means the parallel processing, distributed processing. Okay, we can use up to nowadays 128 very powerful nodes joined together to run the database. Okay, so inside each node we have different slide. Slide means a portion of CPU memory and hard disk resources, so that we can have the parallel processing. Okay, imagine just a few hundred nodes work together your database. Okay, so this is purely for analytic. Okay, OLAP. Normally people just store the process result, keep append into the Redshift. Okay, so at the end you can use SQL statement or use some visualization tools to analyze those data stored in Redshift. Okay, they are very structured. We use SQL statement. We will talk about Redshift a little bit later. Okay, we have one module talking about that, but of course we got 3 days data warehouse coursing just focus on Redshift, and I deliver that course a lot of time already. So for other structured data, the difference comparing with Redshift, relational database is OLTP. Okay, online transactional processing. A lot of concurrent data, a lot of insert, update, delete, and focus on now. All right, that's the online transactional processing. Actually, for most of the engine, you can store up to 16 terabyte data at the moment. Okay, that's the limitation for EBS volume. Okay, not for RDS actually, because EBS, the maximum size is 16 terabyte. That's why if you use MySQL, Marina, Progress, Oracle, Microsoft SQL, 16 terabyte. But if you use Aurora, the product they build themselves, and then you can store up to 128 terabyte data, because Aurora doesn't use EBS. They use custom volume. Your data is distributed across 3 AZ, have 6 copy. That's the beauty of Aurora. All right. So by using RDS, you can change the IOPS. All right, just change to a faster disk to have a better performance. But of course, you pay more for that. So your EMR, your output, you can directly save in the relational database. But of course, just like we mentioned this morning, we can use these tools, SQL to Hadoop tools, to parallel copy those data to RDS or from RDS to your Hadoop file system. Okay, and module 6 we will talk about the MapReduce, that time, and some other data, especially unstructured data. It is possible that you save in Hadoop file system. It means that save in the EMR storage. Okay, but it is not really recommend. If you save the data here, it means that you cannot terminate the EMR after you finish your computing job. All right, so it is better for us to save, offload to S3, DynamoDB, Redshift, RDS. But by storing those data here, we still can use HivePick, Spark to analyze those unstructured data. All right, but we can store those immediate data, intermediate data. It means when you process, okay, after the first step, maybe you store locally, but after that, we immediately get those data to do the second step. Okay, so this is just intermediate storage. Okay, you can use Hadoop file system, but at the end, after you finish the whole process, you better save in S3, Redshift, DynamoDB, etc. All right. So EMR FS consistent view. One key concept for that nowadays is you don't need to care about that anymore. All right. This consistent view basically is because as I put the result, the link in the Slack channel, because S3 was eventual consistent, so that it check the latest copy so that you can perform the read after write. All right, so it means that if you store your data to S3, make sure that this is strong consistency, but you no longer need this. Okay, I can show you the official link, EMR consistency view. This link I can post to Slack channel. Okay, so the important concept, as you can see here, you no longer need EMRFS consistent view, because since last December, S3 is strong consistency. Okay, the consistent view is basically just resolve the problem of S3 eventual consistency. Okay, so nowadays you don't need to care about that because S3 is already strong consistency. Okay, so nothing concern anymore here. For EMR, this is related to EMR. For EMR, actually, let me get back my pen. For EC2, let me talk about EC2 first. For EC2, we have the instant store, ephemeral storage. Okay, I say instant store. This is EC2 things. And then EBS. Instant store means suppose you shut down the instance or the computer hand, you lose your data. All right, that's instant storage. That's ephemeral, non-persistent. All right, and then EBS is persistent. So when we talk about EC2, we talk about that. All right, but now for EMR, Elastic MapReduce, we have the Hadoop file system, right? HDFS. Most likely for HDFS, we have some size, maybe 10 terabyte, 100 terabyte, depends on what EC2 instance you are using. Suppose the HDFS size, you find that this is not enough. What can we do? All right, we can add some more EBS. But for EC2, we think EBS is persistent. However, this is not the case in EML. Okay, because the EML may be terminated, okay, in our best practice after you process. So you add more EBS, basically just want to have more temporary storage for the whole cluster. Okay, but actually, you better save the data into S3 or DynamoDB, Redshift, some other data. So if you are just talking about EC2, instant store is ephemeral, EBS is persistent. But if we are talking EML, all right, even if you add more EBS, your node may goes down, your whole cluster may goes down. So consider those EBS is not persistent, just in EML case. All right. So the EBS on EML, normally we just want to have more storage. Okay, but those storage tied with the life cycle with the instance. If the instance goes down, you may still lose those data. All right. So we increase the size of EBS because I just want to have some more storage in my Hadoop file system. Or you may want to have some faster hard disk provision IOPS for your MapReduce job, for your disk job. All right. So you can add storage to EML. However, yeah, they are not really persistent. And every gig you add, you need to pay more on that. Okay, maybe some instant type, especially the C instant type C5, C6, they don't have much storage by default. That's why you can add some more storage. In the module 6, when we talk about the EML cluster, I show you where we can configure those resources. All right. So it is already 3:30 something. Do you have any question at the moment? Because I would like to have a break so that everybody later on can still concentrate. Is that okay? Let me check. Anybody got questions first? Do you have any questions? Go back to the slide. Yeah, Horace, a very good question. For data store in Redshift, actually, there are a few methods to process. You can use SQL statement, you can use ODBC, JDBC, SageMaker. It is a very good question. I find some official documentation to see how SageMaker can interact. I think we can, but I need some official document to support. All right, I will get back to you, Horace. So, is anybody got some other questions? If no, how about we take a 15 minutes break? 3:50, we come back. Is that okay? Everybody? 3:50. Okay, everybody come back. Okay, thank you. Get back to Horace's question. Before the break, he asked whether the Python SageMaker can interact with Redshift without using SQL statement, but rather we use Python. And I know it is work, it is okay, but I need to find some proof. If you go to this link, I already put it into Slack. Since last year, all right, less than a year, November last year, we have Redshift Data API so that you can interact Python here, but not only Python, but also Node.js, PHP, Ruby, Go, Java would be able to interact with the Redshift together with the SageMaker, not just traditional ODBC, JDBC. Okay, so Horace, you.
Okay. One follow-up question then.
Yeah. Please.
If on my hand I had 1 million of JSON files,
Mhm.
would you recommend me just putting those JSON file into S3 with a partition key, of course, and then I use Python in SageMaker to the AWS Wrangler dot JSON to read it, or I should put those JSON in S3 and then somehow put it in Redshift and then use the SageMaker to read the Redshift? What is the key difference between these two proposals?
Before maybe just S3, but I know nowadays the Redshift also natively support JSON. All right. So if you have really a lot of computing application like join some other document, other table, it is better for us. It is possible for us to put in Redshift nowadays. Normally, when we are going to offload back to S3, if you don't have that much of query, if the query is so often, all right, maybe you have some other raw data joined with the JSON, Redshift nowadays can handle that. Okay.
Okay, so if the query is often and involve a lot of joining, then I should put it in the Redshift. Otherwise, I should just put it in S3 and then.
Yes.
Okay.
Yeah, I can say that. Okay.
Thank you.
But let me just see whether I can find it in a few minutes. Redshift JSON. It's also not very long. Announcement. I think it should be this year.
So in this case, I do not need to put those JSON into S3. I can just put those JSON into Redshift somewhere in Redshift.
Yes. Nowadays you can. It's already GA, but this one is preview. But I know we can do that now. When we are going to offload back to S3, suppose you are greater than 8 petabyte, because in Redshift we can at most store 8 petabyte data at the moment. All right, so less frequent query, you offload back to S3, but a single SQL statement query those Redshift and also external table. External table means Spectrum. The data actually in S3. Let me draw a diagram so that maybe it will be easier for you to understand. So your client, let me use another pencil. Your client interact with Redshift. So Redshift, actually, your data is distributed across the node. Okay, so your data is here. So it is possible for you to offload to S3 so that they will have some Spectrum node query the S3. Still, you interact with only the Redshift endpoint, no matter this is JDBC or the data API. It is possible for us to create external table, and those external table means we talk to S3 directly between Redshift and S3. Okay, rather than you have another endpoint connect here. All right. So if you have more than 8 petabyte, data means we cannot keep all those data. We offload back to S3, but we still connect here. You get my point, Horace?
Yes. But you said I can just connect the directly to the S3, just like the path on the right.
You can connect to S3, of course, always. All
Okay,
right,
but what is
but
the key difference? Is it the efficiency or
the key difference is that do you have existing using some table in Redshift? All right,
no.
if no, you can query directly to S3. But how do you do that? Maybe you need, say for example, Athena. Yeah, but if you have those table, maybe this is the right path for you. Okay,
Thank you.
so you may consider the performance as well. All right.
Mm.
So did I answer your question?
Yes, thank you.
Okay, let's keep going. Okay, so this is still module 4, a few more slides, and then we finish module 4, and we will start module 5. Module 5, we have a lab related to Athena. Some of you already play with Athena, and some other may not. Okay, so yeah, that's a good lab to do. Elasticsearch, in my past experience, a lot of people, not just using AWS, maybe they have their on-prem cluster, all right, Elasticsearch open source cluster, work together with the Logstash and then Kibana, okay, ELK, this one for log, this one Elasticsearch, this one for visualization, Kibana. So it is possible that we say, for example, move some log file into Elasticsearch cluster and then use the open source engine and visualization. If you use Elasticsearch, likely you will also use Kibana. So this is log analyzing solution. You can build it yourself, or some other customer just simply subscribe by the service provided by Splunk. It is similar. But anyway, you got your web server. Let's go back here. You got your web server. You have all the log file through, say, for example, once again, Firehose, raw data, keep it here. And then analytic here, SQL statement, Flink, or the new Studio in order to query your or process your data and then load to Elasticsearch, visualize using Kibana, all right, so that your SS pattern is going to the Kibana and do the rich visualization. Okay, so this is another method. If you already doing something on-prem, you can also do something inside AWS like this. So the factor for sorry, yeah. Okay. Okay. So the data store consideration depends on what is your structure of data. Is it fixed schema, JSON, key value? If key value, consider DynamoDB, Elastic Cache, JSON. Also, you can use DynamoDB, and nowadays Redshift. And fixed schema, RDS or Redshift. Okay, based on the structure of your data, and then the SS pattern. Okay, your user, how they access the data. All right, using SQL statement, using some visualization tools, Tableau, Kibana, all right, and the data, is it hot data, warm data, or cold data? Okay, it affects the storage, and of course the cost. Okay, are we going to minimize the cost or maximize the performance? And let's take a look. Data structure. So if fixed schema, likely SQL, or you may consider some NoSQL. Schema-free, JSON, of course, NoSQL. Key value, Elastic Cache, NoSQL. Graph, then we use graph database. some other open source engine, or use Neptune provided by AWS. So here we take a look. SS pattern. If you just use HTTP put get, yeah, of course you can use S3, and then also Elasticache NoSQL for key value store. And then do we have relations? Simple relations, NoSQL. Very complex relations, of course, SQL relational database, search, Elasticsearch, AWS provided cloud search, graph database. So that depends on SS pattern, and also the hot tier or not. So it depends on the volume. For hot data, suppose I got civil meg, gigabyte, warm data, cold data. We can store petabyte data in Redshift or exabyte data, or even more in S3. Item size is also consideration. Latency, okay, cost, durability, and then request rate. So we group all this into a bigger table for selecting the storage for your big data. So if you take a look here, first of all, is the latency. If you need microsecond, this is Elasticache, means Redis, and also the Memcache. DAX is DynamoDB accelerator, is the cache engine for DynamoDB. Before, many years before, I think 5-6 years before, DynamoDB, the cache still stored in Elasticache. Now it got its own caching service features. Okay, so normally this one for gigabyte of data, because store the data in memory, we don't have terabyte or exabyte compatible. But just a few gigabyte, that's okay. Item size relatively small. Okay, byte to KB, and then very high request rate. Of course, the cost is higher. All right, some of them is actually not so much durability because if you're using Memcache, it's living inside one single AZ. You lose the node, you lose your data. All right, and then 2 AZ or 3 AZ, the availability. So by using this free, normally it's millisecond, 2 seconds. All right, DynamoDB, RDS, Elasticsearch. DynamoDB, we don't have limit. You can store any amount of data in DynamoDB because it's horizontal distributed. And then Aurora. Aurora nowadays is actually 128 meg, 128 terabyte. Okay, but for other RDS, it's 16 terabyte. Okay, so that's the number. And then Elasticsearch up to terabyte. The size, a few KB. Yeah, and then very high request rate. High request rate is cheaper comparing with those Elasticache. And then durability, this too is very high. Is multi-AC, and then 3 AZ. You can have the Aurora RDS across 2 AZ or even across region. For DynamoDB, you can have global table. Your data can be having another copy in another region. So here we have AC availability. But normally for S3 Glacier, just because of the cost, it's very low, the price, but we can keep petabyte or even exabyte of data. All right. But here the request rate is very low, a little bit low. So when we choose the storage, we take a look on this comparison. Okay, depends on the budget. One interesting story related to that is, suppose I select the storage. If you choose either S3 or DynamoDB, DynamoDB, of course, could be structured data, semi-structured data. S3, actually, any data could be unstructured, could be structured. All right. So if you just every second 300 write, this is the same. Okay, the only difference here is that the size is different. Okay, here 2K the object size. The second scenario is that 32K. All right, and then just do the calculation. Every month you got 1,400 gigabyte data right to the S3 or DynamoDB. Here much more. All right. So after doing the calculation, let's take a look on the scenario 1 comparing S3 and DynamoDB. So for scenario 1, the cost, we are now looking at the cost, is that S3, the amount, every second, 300 write continuously for the whole month, really a lot of data write into S3. Storage price is super low, okay, just $34 every month. But every request, you need to pay for that, okay? So by so much amount write to S3, the HTTP put get list, you need to pay for that, and then $4,000. All right, but for DynamoDB, the storage and then throughput, okay, DynamoDB charge us for the read capacity unit and write capacity unit because the object size is small. Okay, so relatively low throughput, low write capacity unit, we can still handle. So by doing that, actually, DynamoDB is cheaper in this scenario. Okay, so next scenario is that the object size is much larger. Before it's only 2K, now 32K. Okay, so S3 is similar. The put list is the same. Okay, storage a little bit more. Okay, because I got more data, a larger data. Okay, it's still 4,000 something. But if you use DynamoDB, you need a much bigger throughput, and also the storage price increase. So it is much more expensive in that case. Okay, so in this scenario, you really need to use the calculator to do the calculation. For smaller object, maybe S3 is better, but for for small object, maybe DynamoDB is better, but for big object, maybe S3 is cheaper. If you take a look on the price point of view, all right, could be very different. Okay, since in DynamoDB we need a very big throughput write capacity unit. I can tell you a story related to Expedia. You can find it in case study, AWS case study. Expedia, the company inside case study, I can tell their story, but if they're not in case study, I better not say anything. For Expedia, okay, is it something like that? Okay, they do a lot of case study. You can take a look inside. You can find, actually they store the comment. Okay, after you stay in the hotel, you can write comment, right? The staff, the food, convenience, is it clean? Before the pandemic, every day they got more than 100 million comment every day. Okay, and this is very crucial to their business because when you book the hotel, you also take a look on some other people's comment. So at first they use DynamoDB, okay, and because they got really huge comment, all right, they're not very structured data. Is some of them is semi-structured or even unstructured. Right into the database, they need a very big write capacity unit, okay, and read capacity unit, and then the cost is very high. Okay, so what they do is they change from DynamoDB to Elasticache. And I'm not saying Elasticache is cheaper, but I'm saying that the method to pay is different. Okay, DynamoDB charge you the pipe, okay, read and write capacity unit. But for Elasticache, they just charge you the storage together with the uptime of the instance. If the instance is up, no matter how much data you write and read from the DynamoDB, from the Elasticache, the price is the same. Okay, in many cases, DynamoDB could be cheaper, but in their case, because they need a very huge pipe, very expensive on the throughput, then after that change, they save a lot. Okay, there is really a case study. You can take a look from their website. So what I'm saying is that sometimes you just change to use some other service. Maybe you save a lot. Okay, as you can see here, you save more than 50%. Okay, so that's the scenario. That's very interesting. Okay, let's keep going. What you can do is you can go to take a look on the calculator. AWS got a lot of calculator. The newest version is price calculator. Let me search it for you. AWS price calculator. Okay, this is the most updated version. Do not use the old version, the monthly calculator, okay, because they didn't update anymore. All right, so this is very good one. You can start estimate, and then let's say I'm going to use DynamoDB, and then you answer some question, and then they can still start calculating what you are going to use, okay, and then how much per month. Okay, this is the simple monthly calculator. Use the new one as calculator. So let's take a look on some case. AppRow is one of the AWS customer. They are all in. All the backend infrastructure is on AWS, not hybrid, 100% on AWS. Okay, it's an advertisement company. All right, they have every day, hundreds of terabytes of data, and then they want to have a very slow response time, and then every second they handle more than 1 million global requests from all the customer, all the app. So the solution, actually, we just take a look on what service they use. They have a load balancer, of course, EC2, and then capture those data by using Kinesis, okay, and then store in S3, and then use some third party, not just everything from AWS, Apache Storm, and then store those data in DynamoDB and start doing the bidding. All right, and the key point is that they can actually serve the demand, save a lot, the storage, and then the read operation, and also the cost. Save the storage and throughput costs. Okay, but if you want to have, here we just have three slides. If you want to have more details, AWS case study AppRow could be much more detailed, the scenario. Okay, and some link for that. Okay, and a video for that. Okay, so they make a lot of case study. Normally, most of the case study cheaper, faster. All right, serve the demand. So let's take a look on this module review. What are the true reasons that you use the DynamoDB? Because we don't have schema. And module 6, we are going to talk about, the Hive, it is compatible. We can query the data, integrate with S3 together with DynamoDB or some table inside Hadoop file system. And then from highest latence, lowest to highest latence, okay, DynamoDB is fast. If you want some more faster, we can use the DynamoDB accelerator and then Elasticache. Okay, these are very hot here. And then DynamoDB, and then Redshift, S3, Glacier. Okay, from lowest latence to highest latence, or from fast to relatively slow storage. And then highly structured data, of course, RDS or even Redshift. Okay, but now Redshift support JSON. Okay, since last year. So this is related to the data storage. We don't have lab on that, but still important and quite long, this module. Yeah, let's move on. If you have questions, you can always ask, post in Slack, and we keep going. The last module for today is this, actually focus on Athena. After I finish my presentation, maybe half an hour, 45 minutes, and then we start doing the last lab. Okay, so that's the lab 2. Okay, I should do something first, because when you go to awsquicklab.com and let me start lab 2, it takes some time to provision. Oh, this lab we don't need to wait. Very good. For some lab, they need some time to provision. All right, and it takes around 30 minutes to finish this lab on average. Okay, so I don't need to do anything because there is not so much provision time. Okay, so this module is about, we start talking about processing. Okay, before module 2 and 3 about ingress. Last module, storage. Okay, we have just different type of storage for unstructured, semi-structured, for hot tier, low tier, different type of data. And this module, we start processing. Tomorrow, whole day, we talk about processing. Okay, so how to process the data. Okay, once again, we can use EMR. Many years before, people use Redshift, but nowadays, less likely you will use Redshift to process. Okay, because we got much more choice nowadays, especially when you do the ETL job. Okay, before people really use Redshift, so that at that time we call it ELT, load to Redshift first, and then do the transformation, process your data. But now we have a lot of other choice like data pipeline, like Glue, or even Lambda function, SageMaker. All right, so we nowadays see them use the Redshift to the processing. And the topic here is about, we sometimes just want to write simple query, ad hoc query. It is not continuous. Maybe every 2 weeks, I suddenly want to write some query. Okay, yeah, just ad hoc. I don't know when I'm going to process. Okay, it is not having a fixed interval. So this topic, starting from this topic, we talk about process. Okay, tomorrow, EMR whole day, we talk about processing. Okay, so as you can see here, just like in the Lego, the picture here, we got really a lot of source data. Of course, we better categorize them first. Okay, actually, Kinesis is doing something like this. The Kinesis data stream, and they do it very quick, within less than a second, from this to this one. All right, and then we can then use the data to do something good. All right, just like this, to build anything that you want. All right, so that's data process. Okay, just the concept. Yeah, we might need to inspect, clean, transform the data before we need to do the process. And then we make decision, answer the questions based on those data. So the challenge of big data, once again, we have real-time data. We have some data very complex. We might want to interact and run some ad hoc query. All right. So how can we do this? Okay. So let's take a look, understand the pattern. We might have batch data. Normally, this one we have interval. All right. Every day, every week, every month, every quarter, we run some report. Okay. Traditionally, it takes hours, minutes, or even days to run. Okay, monthly report, daily report. This is example. Interactive analysis. All right. Sometimes I just want to quickly have the answer. Self-serve, want some maybe SQL statement. All right, so that I get some insight. All right, using some ad hoc interactive query. Okay, so we may also have message. Think about the IoT device. Okay, the input ingression method and then outbound control method. Okay, from millisecond to seconds. We have stream data. Module 3, we talk about that more or less continuously. Okay, Kinesis or Kafka or from yeah, something like that, or the Fluentd Storm. Okay, so fault alert, something happened, then we need to be notified. Think about the oil gas company. All right, if something happened, could be very dangerous. All right, machine learning. All right, and then we want to do some forecasts. So some of them, it is possible for us to wait a few minutes, hours, but sometimes some other, we want seconds in order to make respond. All right. So here we have the batch job. A batch job normally same query to different data set. Okay, every week, every day. Okay, we want to know about the revenue, the gross profit, the whatever cost. All right, same query, but for different type of data. Okay, different period of the data. All right. So of course we can use Hadoop MapReduce. Tomorrow we will talk about that. So for query engine, normally we have repeat query over the same well-structured data. Maybe repeat query, maybe different query, but same set of data. Here we have same set of data. Here we have different set of data, batch or query engine. But for query engine, likely data warehouse, and then the NoSQL database, okay, repeat query with the same data. So the approach of the big data processing, let's go back here, stream data, nearly real time, and then simple computation. Okay, not so much join, just quite simple. All right, if the temperature go up, what are we going to do? How we are going to ingress those data into our stream, and then easy to scale, persist our data. Okay, sequential process the data. Likely those streaming data, we work with the Kinesis family or third-party tools. Okay, so for batch data, it's relatively cool. 10 years, 12, 15 years before, a lot of example with this. Okay, quarterly report, monthly report. Okay, take a look on our performance. Are we meeting the KPI, key performance indicator? Many years before we talk about that, and now not just the cold data. Okay, not just hourly, weekly, monthly, quarterly, but also some hot data. Okay, take a look on our metrics. Anything goes wrong, anything abnormal, real-time detection. Okay, so that we can respond in a much quicker time. The stream processing. So to understand those big data processing, different industry, let's say e-commerce. All right, is our customer engaged? Are they happy with the clickstream? And then for digital advertisement, all right, this is just another scenario. Yeah, are we covering the user happy? Are they going to bid buy our product? Financial, once again, very important. Every single second, the stock price change. Can we find anything abnormal? Can we also interact with those things? And then technology. Okay, are we being DDoS? Is there the IP address come from Russia, come from Middle East? So we need to know if anything abnormal happened. All right, so just yeah, every industry could be able to benefit from this big data processing. This is just some example. So suppose I want to run some ad hoc query. All right, I want to analyze now. I don't want to wait 2 weeks, 3 months later. Any time in a year, I just want to run something. So say for example, you have really a lot of click stream from all of your customer. Okay, maybe hundreds of petabyte, hundred of gigabyte inside S3, and you want to take a look. Oh, let's say, do we have a slow loading to page last month? What are the keywords searched by the customer? All right, what is their interest? All right, so what we can do, we can build a long-running Hadoop cluster, load all the data, and then query. But maybe every single month, I just want to query 1 or 2 times. If you keep the whole Hadoop cluster, you waste a lot of resources. You can copy every data into data warehouse and then query by using SQL statement. But both is not good enough if this is just ad hoc query, okay? Because when you build, no matter EMR cluster or Redshift cluster, okay, there is cost associated with them. If just for ad hoc query, that's not so good, okay? So what are the better choice and what can we do? Example of this ad hoc query, yeah, you need to maintain the Hadoop cluster. We need to understand the whole EMR Hadoop ecosystem, data warehouse. We need those experts. We need to understand what is HDFS data warehouse. But what can we do to make it more simple if we just have ad hoc query? So we can simply, as last module, store those data in S3 and then use direct SQL query to those S3 by using Athena. Okay, as we all know, the data stored in S3 many years before, you need to HTTP GET download the data first. And then you got the zip file likely because they are all compressed, unzip it, and then take a look. But now, a few years before, since we have Athena, we can directly run some SQL statement according to the schema, all right, that you apply when you read the data. All right, this is not schema on write, rather schema on read. Okay, suppose I have the log file. I want to run a ad hoc query. It's easy because it's just SQL statement. Okay, so this interactive query service, some of you already using it, and it is very good that we use SQL statement to query the data on S3. We apply the schema when we read the data, all right? Because by using SQL, you still need to know what table, what column are we querying, country, date, product, or whatever column, okay, that you want. We support cost region, okay, query, and then use standard SQL statement. So for those database guy, nothing to learn, all right, related to the language, all right. No infrastructure to create because it is just serverless, all right, to you, okay. Of course, under the cover, AWS must have server, but to the customer, you just create the schema and then apply your SQL statement. So easy. So directly query from S3 could be seconds, and then you can get your result. No infrastructure, no server to maintain, pay per query. And actually, they pay for the data that you scan. Okay, so if you scan less data, then you pay less. Okay, so how can we do this? 3 typical method. One is partition in S3, just like create multiple folder, scan which folder, and then compress and columnize. Remember these 3 things, okay? Partition, and then the first thing, to reduce the number of data that you scan. Second is compress. This is best practice. And then third is columnize the data. All right. So these three things can save you a lot, okay, for running this Athena. Under the cover, technically, they use Presto. This is a distributed query engine in memory, so super fast. We will talk about Presto a little bit tomorrow, okay? And then Hive. Hive is basically that you don't need to write the very low-level coding. You don't need to write Java. You just use SQL statement, all right? And then you apply the schema when you read the data. And then we also support complex data type, different format. We support partition, okay? So that you don't need to write the low-level program, okay? So by using Athena, we can analyze the application log, the web server log. Let's say this is the web server log. We got some dates. We got the data file in different folder. Maybe inside, say for example, web server log, we have the response. Suppose 200. The web server respond, then you're happy. And if you see a lot of 404, 403, object not found, and then forbidden, all right, anything redirect, the IS Apache server error. So you don't want to, you want to reduce the number of error, right? If your customer keep hitting error page, they are not happy. All right, so we might want to analyze, reduce those things happen. So we analyze log to do something to make adjustments, okay, to make your website better, your application better. So not just write the query with the result, but also we can integrate it with some visualization tools. If you use AWS QuickSight, we support a lot of source. We support directly from S3, but if the data is not already processed, it is not good. Yeah, we support RDS, Redshift, but also Athena. We write the query first, and then at the end, visualize using QuickSight. So it is still the same data pipeline. Remember, we ingress the data into now S3, but we are ready. The data could be paste a schema anytime, and then we use Athena mainly for ad hoc query, and then the QuickSight. Okay, so ingress, storage, process, and then output, visualization. Okay, the pipeline is still the same, but for different purpose. This is for ad hoc query. So Athena use case, because we store the data in the data lake, so the data is ready. Okay, ad hoc query. But if the query is not just ad hoc, we already have the Redshift. We can also run SQL statement here. Okay, when we are going to use Athena, the keyword is ad hoc query. But if every day, every week, every month, we already having some historical analytic, in that case, maybe you can still go to Redshift to connect your S3 as the data source spectrum, and then run those ad hoc query. Okay, if you don't have this ready, then you can use Athena anytime. And then using S3 as data lake, yeah, we can consume those data. Suppose likely unstructured data, we use EMR. All right, for the Redshift and Athena, likely they are relatively structured data, and use QuickSight as visualization. If you don't like QuickSight, you can use third party, like Tableau. Really, a lot of people nowadays use that. Spotfire, and then also Power BI, yeah, something like that. And when you apply the schema, because your data is originally stored in S3, okay, likely they are just file storing in some what we say folder. Actually, folder in S3 is not really a folder. It's just prefix. Okay, this concept, I think we need to understand that it seems to you that you can create folder in S3, but they are really not a folder. Suppose you have a file one, and then you create folder one. What under the cover they do is, before the file one, your file is no longer called file one. It's called folder one, and then slash file one. All right. So this is what really happening. S3 is very flag that even if you got billions of files, they are placing very flag. We don't have folder structure. Folder is for you to see, and by using folder, by using this prefix, we can scan less data. All right. One very good example we can use is that use the days, the year to create those folder or more specific prefix. Okay, so that's why we need to create the schema. All right, the schema can be created inside Athena. If you do this, they are using actually Hive under the cover. But now you can use Glue, okay, as the schema. All right, so the data catalog, the metadata stored in Glue, it is possible to do so. If you got some other query also using those by using Glue, so you can share with other AWS product. Okay, then we can integrate it with Glue. But if you don't want to integrate, it is possible that you just use the default Hive as the data catalog. All right, identify the schema. So the data lake, we have data source. It might come from IoT device. It might come from mobile application. It might come from anywhere. All right, the log file. We store in S3. Yeah, you may have EML, long-running cluster, transient cluster. We will talk about that tomorrow to process your data. Once again, after you finish, you better, it is recommended that you terminate your EML. And then the result you save in S3, all right? And then you may also copy all those structure result to add Redshift and then use the QuickSight. But sometimes I want to run some ad hoc query, okay? And then you can use Athena. Not only your original raw data, but you can also use Athena to query the aggregated data set. Okay, so this part is more or less ad hoc, all right? But maybe periodically, you also use EML and Redshift to process your data. So Athena, the UI is something like that. So you create this data catalog. Okay, that's what we call schema on write. Oh, we have a table. Inside that table, we have the dates, string, integer, some name, host, whatever. All right, browser, find OS version. And then after you create this schema, okay, and then you can use your SQL statement query this table. And then this is just SQL statement, select where from whatever. All right, so the table column, we can use internal catalog, or we can save all this into Glue. Okay, that we mentioned before. Later on, I think tomorrow or Wednesday, we will talk about Glue. So Athena concept, we use SQL statement. All right, the data definition language, just like create table, job order, the object, and then DML, just insert, update, delete statement. Okay, and then we can also use the control language to grant, revoke the permission. This is just simply SQL statement. If for a database, I mean database developer, they don't need to learn. All right, it's the same thing. And then Athena table, yeah, the data definition language is written in Hive. Under the cover, they use Hive. That's why we call it schema on write flexible. Athena have their own meta store. or once again, you can use GRU. And actually, you can store in RDS. If you share this Athena with multiple customer, okay, and then we can actually save those data, the Metastore in RDS. Suppose you use many EML, different customer, okay, and then we support common data format, okay. Athena, this is different from S3. S3, you can create partition. That's basically the S3 folder. But in Athena, we can also create partition. So we reduce the number of data scan, okay, just for cost saving and better performance, okay, and work together with the complex data, and then also the columnized format, okay, to reduce the data scan further and further to have a better performance and cheaper query. All right. So internal data catalog means just inside Athena. All right. This is just data catalog. Okay. What are the table? What are the columns? What are the data type? Okay. String, integer, double, big integer, whatever. All right. So this is the data catalog. Okay. Inside Athena or use GRU. Okay. Your choice. It's just like the Hive Metastore. So we support a wide range of format: CSV, JSON, web, log, Apache, IIS, customer, text file, RAW format, okay, and open source column line format. Okay, it is recommended to make it more Pacrid OCL column line. Okay, so that we scan less and less data. All right, and for Pacrid, actually we can push some operation to this level, to the code level, so that instead of return all the data set and then you filter the data from this pass to you already summarize all those data to reduce the number of data transfer back to your system to make it faster. All right, so this is some open source format good for you. You can select. Here is just the step-by-step creating the Metastore or data catalog. All right, so you are going to play with it in the next step, next lab. So some example, if you just store as text file without column lines, a terabyte data, you run the query almost 4 minutes. All right, and then scan so much data, 1 terabyte, and then cost you $5 just for that query. Okay, $5 just for a single query, because you scan so much data, and then 4 minutes you need to wait. Okay, get a coffee. But if the data stored in Pacrid format, okay, you scan, the size is much smaller. Okay, the original size, but you scan, yeah, only maybe 2. This is just one case. If you want to take a look on this case, I can give you the original link. This is really, I put it into Slack. Some company, it's a real case. Okay, yeah, around 5 years before, analyze using Athena. The data is originally in S3. This is the whole scenario. Okay, it's quite long. And then for this case, yeah, they scan much less data. And then you pay for, not only you pay much less, reduce 99.7%, but also the query is much faster, just 7 seconds. All right. So if you want to take a look in the further details, take a look on that case study. All right, the blog that I just post in the Slack channel. And then for Athena, likely you query the data from S3, but tomorrow we will talk about we create EML, not just ad hoc, maybe 4 hours, 5 hours a day, I query those S3 data. Or you may create long-running EMR. That means the EMR will not be terminated. Okay, but of course the cost is higher, but you can run those jobs anytime. Okay, and Redshift, we can also consume the data. As you can see, S3 is the data lake. You can use multiple methods query those data. Ad hoc query, structure, relatively long-running job, okay, or unstructured, semi-structured job to get the same set data from S3. At the end, we also could use some visualization tools like QuickSight from AWS. So Athena, ad hoc query, the concept is there is no limit because S3, we don't have any limit on the data size. Serverless, Athena is serverless, but the storage should be inside S3. We support a wide range of format. Think about columnized format, okay, to reduce your cost and better performance. And then inside Athena, we have the internal catalog, or you can use Glue once again. And then we use the same JDBC tools, connect to them. For permission, of course, AWS Service, we use IAM role. But by using Athena, we don't support user-defined function at the moment, all right? If you want to write your function, maybe you can consider Redshift or other tools, okay? So case study, another company, DataSoup, once again, bidding company. Every day they got more than 180 terabyte log file. Okay, so they build a pipeline, how they are going to ingress the data from their content delivery network, bidding, and some other platform. Ingress using Kinesis, okay, petabyte of data ingress into the pipeline. And then, yeah, they use S3, and then visualization, ad hoc query, they use Athena, and some other third-party reporting tools. So once again, if you want to take a look on this scenario, how they use it, AWS case study, or this is my architecture, okay, for details. And then name some benefit of using Athena. Of course, SQL statement we support, easy to use, and then AWS managed. We don't need to care about all the underlying availability and scalability patching of those services. Direct run query. We don't need to download, extract those data. Just write your SQL statement, your query. We support Picrete, OCR, CSV, RAW format, JSON, okay, and text. The store, we can have the Athena internal catalog store or Glue. All right. So it is about time to start lab 2. Actually, we just talked about Athena, but how to do it? Okay, this is the step. So if you want, you can start doing lab 2 now, or you can do it later, your choice. But yeah, it takes around 30 minutes. After you finish this lab, if you got no question, you can leave anytime. If you want to do it at a later time, night time, you can leave anytime. All right. So do you have any questions related to this today, the topic? Anybody? Roger, can you see the lab now? And your colleague, Kathy, can they see the lab now? How about Elvin, Timothy, Pat, and William? Can you see the lab? Any questions? Any feedback? Is it too fast, too slow? What is the fastest, easiest way to move? Okay, Elvin. Elvin, do you have any questions? Or your colleagues? Make sure everybody. Let me, Darren, let me think about what is the best way for doing that. Actually, I have a lot of method. Yeah, okay.
I'll talk about my scenario.
Okay.
I have multiple
Mhm.
DB of the exact same schema
Mhm.
because different customers sit on different DB, or
Mhm.
their data sit on different DB. I mean,
Mhm.
now I have a reporting portal. I want to query from these different DBs to
Mhm.
get my data, but the join is tremendous if I want to query each DB and then join inside the, let's say, API controller.
Mhm.
So I'm thinking of
Moving to S3 and use
yeah,
Athena.
yeah,
So
yeah,
is it ad hoc or a really long running query? I mean,
ad hoc,
oh, okay.
definitely ad hoc.
Okay. So my first idea is Glue, but I need to go into details that meet all of your requirement, like Pacrete, something like that. But definitely, I think it's the answer is Glue. But let me get the right documentation for your scenario. Is that okay?
Yeah, I have read a bit about Glue and it's a bit expensive, costly. I mean, I want to go for the pricing as well later. I mean, keep
Oh,
the best part later. I mean, yeah,
uh-huh.
we'll go for the lab first.
Okay, okay.
Yeah,
So, and I read. How big is your data, Kelvin? Is it terabyte?
Just maybe 10 gigabyte.
10 gig. Okay.
I don't know, but when I try it in SageMaker, it takes within 1 minute. But I don't know why when I transform it from SageMaker to Glue, then the whole process take around 3 hours, I think.
3 hours.
Yeah, I don't know why, but the code is the same, so I have some. Yeah, I don't know why.
Okay. There must be something wrong. Shouldn't take 3 hours for transforming a few gig file. For your case, actually production, we have really a lot of case. Do you have AWS support so that they can take a look inside your scenario? I mean, the technical account manager. Do you have business enterprise support on that?
Uh, I'm not sure. Maybe
Okay.
I have. Then should I ask him a question like
You can if
on
you have.
this? Yeah, yeah.
Yeah, in some project I work with the customer, they have
Uh-huh.
business enterprise support. You can open unlimited case, and they
Okay.
need to respond you. Because yeah, they can not only see something within your AWS account, they can see something under the cover as well. All right. So
Okay.
yeah, so that they may get more insight. Not everything you can see in your account. All right.
Okay.
So
Okay.
I think in your case, you better open a case
Okay. Okay.
to see what they can do. Okay.
Okay. Okay. Let me
You
try.
pay
Yeah.
you pay for so much for for yeah support. All right.
Okay. Okay. Thank you.
Yeah, because it's if just one sentence, we don't know yeah anything under the cover. All right.
Okay.
Yeah. Okay. So you can
Okay.
try first.
Okay. Thank you.
But if you need further help, I can escalate and see anybody can help. Okay.
Okay. Let me try first. Thank you.
Okay. Thank you. So if and now let's start doing lab 2. Please do lab 2. Yeah, if you finish and then or if you want to do it later, I see you tomorrow 9:30. Okay, and we will keep the WebEx to around 5:30. After that, I will close the WebEx. And then if you still got any questions, you can ask in Slack. Okay.